Hi, jury members. Those of you here with us today in this room, and all of you joining us online. Welcome to the office building division. Healthy and resource efficient office buildings are the cornerstone of our services-based economy. Net zero energy office go beyond the standards set by energy conservation building code, significantly cutting energy use and reducing carbon footprints. I'm thrilled to welcome you all to the office building division, where these students are reimagining the future of office design. My name is Dhanashri Mankar, and I am the MC for today. It's my job to keep us on time, and I'll be taking this very seriously. Our finalist teams have put in a lot of hard work. They submitted their project reports about a month ago. And today, these teams will present their work to the jury. So teams, you will have 20 minutes for your presentation, followed by a 10 minutes Q&A session. There will be a 5-minute break after that. So for those 5 minutes, you must use those to take your component model and allow the next team to bring in their model. Okay? So the office members who have expertise in net zero and resilient buildings. So we have Sangeeta Changiani, who is the founder for Innova. Hello, Sangeeta. Next, we have Sandeep Dodballapur, Director at Environmental Design Solutions. Hello, Sandeep. Our third jury member is Dheeraj Wadhwa, who is the Director for Commercial and Overseas Business at Career Corporation. Hi, Dheeraj. Morning. So now these jury members have had 3 weeks to review the report submitted by the teams. They have looked at your work in detail and have already assessed your entries for the 10 contests of the decathlon. They have looked at your work in detail. Now teams, your presentation will help them hear your narrative today. Contests of the decathlon. They will assess your presentation now and your mastery. Your presentation will help them hear your narrative session. They will assess your presentation. They may also revise your scores based on what they hear from you through their Q&A session. So jury members, I'm so excited to revise your scores based on what they hear from you. I will need to interrupt people. So jury members, I'm so excited to have you meet the teams today to help us stay on time. Interrupt people. Please don't mind. Including you from time to time. I'm looking for your support in this to help us stay on time. Please keep your comments and questions. I'm looking for your support in this. Okay. Please keep your comments. So are we ready to begin? And questions, short and to the point. Okay, so let's start with the presentation. So are we ready to begin? Our first presentation is from Team Gen Zero. Start with the presentation. They have worked on a project called Zenith Spaces, which is located in Kharati, from Team Gen Zero. So they are presenting on a project that tries to exemplify the principles of regenerative architecture, integrity, they are presenting something that tries to exemplify the principles of regenerative architecture, integrity, net zero, energy, water, and carbon strategies. So the team, the stage is yours now. Okay. So team, you will have 20 minutes to present your work to the jury. At 15 minutes, I will ring a signal like this. You won't be having a 21st minute, which means at 20 minutes, I will stop you and ask you to end your presentations. Okay? After that, we will have 10 minutes Q&A session. So please keep your answers direct and to the point. All right? So, okay, the stage is yours. You may begin and your time starts now.
Hello. Good morning, esteemed jurors, faculty members, and all fellow participants present here today. We are Team Gen Zero. Today, we proudly present our net zero office building. This project is our response to the growing need for the regenerative architecture, energy efficiency, and a wellness-oriented workspace in a fast-growing city like Pune. Zenith Co-Works exemplifies the principles of regenerative architecture, integrating net zero energy, water, and carbon strategies to redefine commercial workspaces. Our design inculcates all the 10 contests given by the Solar Decathlon India, and we have incorporated same in our further design. Kharadi, located in Pune, has evolved from a small town to a major industrial and IT hub within the Eastern Metropolitan Corridor of Pune. Fueled by its IT boom, the suburban constantly reinvents itself, rising towards the rising buildings, glass towers, and the IT companies. The triangular form of the site and the approach road towards the site has helped us design our building and develop the form of the building. The site is located between two tall towers rising from 80 meters to 108 meters towards the southern and the northern side of the site. We had not only 1, 2, or 3 requirements from the project partner, but there were quite a good number of requirements from the project partners that we got, and we have incorporated all those in our further design process. Our initial goal was to design a modern, aesthetic, and energy-efficient building that balances sustainability with functionality, and we have successfully achieved it. The architectural form follows a stepped form. The conceptual form emerged from simulations of light, heat gain, and shadow analysis, resulting in a stepped design. For a month, we did radiation and shadow simulations, wherein we got that the roof receives the maximum solar radiation as it is perpendicular to the sun. Also, due to its peculiar orientation, all facades receives average radiation throughout the year. The northeastern facade is shielded from direct sunlight for most of the day, providing diffuse daylight and ventilation. The planning features an open workspace wherein meeting rooms, conference areas, lobbies, and terraces are designed to promote collaboration, comfort, and productivity. The total built-up area of the entire building is 8,154 square meters, out of which 70.9% is of the office space, in which around 800 square meters of area is given to the open terraces. The site has 2 approach roads. One goes directly to the basement and one is directly exit to the site. We have tried to keep the circulation to the site of the circulation of the vehicle to the site to the minimal so as to have a smooth circulation all around the site. On the ground floor, as per the user analysis and the discussion with the project partner, we got to know that we'll have a 2-wheeler parking as well as the retail spaces, which was the special requirement from the project partner on the ground floor itself. Hence, we have 5 retail shops and 2-wheeler parkings as well as an entrance to the building on the ground floor. We have total 9 levels of office spaces with open terraces on each floor. The building envelope includes colored glass, southwest water tank, and green terraces, which we'll be discussing in the further part of the presentation. The vertical zones have been divided into 4 different levels. That is, the lower 4 levels are the 4 basements for the car parking. The ground level is for the commercial area and the 2-wheeler parking. The above 9 levels are for the office spaces with open terraces. The terrace floor to house the services, and the service code on the northern facade of the building. Our design process started with understanding the challenges that we had on the site and in and around the site. We identified our project partners, and the meetings with the project partners led us to know the requirements of the project partners that would be needing to work on the design. The site visits, case studies, and goals of the project, goals and the project requirements. The site analysis and exploring the local materials in and around Pune. developing design program and initial analysis of the 10 contests of the sustainability, integrating sustainability strategies and our live experiments and getting the data and user analysis from the experiment we did. Design integrated prototypes.
Coming to the operations part of the building, we have incorporated a 3-stage evaporative cooling system in which the first stage consists of the indirect and direct evaporative cooling. The air cooled in this unit further enters via the duct into an indoor unit. The third unit consists of a refrigerant, which is a VRV system, and the cool refrigerant from the third stage enters this again the indoor unit. The air cooled into the indoor unit further enters the spaces, that is the interior spaces. The air, which is the stale air from the interior spaces, is exhausted from the building naturally through the corridors and common waiting areas. Dehumidification water, which is there, is pumped back into the evaporative cooling system. The 3 stages operate in such a way according to the need of the season for the particular month. We have also used a BMS, that is a building management system, also with the DALI integrated lighting system, wherein we collaborated with our industry partner, that is Sahyog Designway. Here, the system helps us in controlling HVAC, security, safety, plumbing, electricity through one particular server. This helps in reducing the energy bills of the building, at the same time enhancing the occupants' comfort. The DALI-based lighting system is a sensor-based lighting system, wherein a DALI sensor is attached to the lighting system, which can control the amount of light in a particular area. For example, in corridors, we do not require light throughout the time. So if a user is using the corridors, the light would get switched on. We have CCTV cameras, which are AI enabled, which can detect the presence of a person in a particular area. So in case if a person is not there, we can actually switch off the fixtures to make our fixtures more energy efficient. We have also developed a Gen Zero app, which sends notification to the user in case a user activity is not been detected in a particular area. For thermal comfort of the building, we have made PFA soil blocks with bagasse insulation, wherein these help in reducing 7.38% energy consumption, which also decreases the indoor temperature by 3 degrees and helps in heat time lag.
Now, let's move further to another design innovation, which is the wall integrated water tank. As the name suggests, the core idea is very simple. A water tank which is integrated into the wall. We have provided this water tank on the southwestern side to act as thermal buffers. Since water has a very high specific heat capacity, it is able to store a large amount of heat during the day. A cavity wall has been provided on the internal side of the water tank, which avoids moisture from seeping into the workspaces. The water tanks are integrated into the building using a system of post-tension beams and shear walls.
There are 3 different water tanks. 2 are for the municipal water tanks and are also for the rainwater harvesting tank. Sorry, the treated rainwater rainwater, and 1 is for the treated STP water. The water that comes from the treated rainwater harvesting are stored in these 2 tanks, and the treated STP water is stored in this particular tank. Towards the southeastern side, we have our toilets. The water comes from the underground tank, and it directly goes to the 2 tanks that is there on each level. So every floor has 3 different tanks on every floor. All the tanks are not connected. Each tank is bifurcated by a slab within the floor itself.
Moving forward to health and well-being. Our approach blends passive and active design strategies. One such strategy that we have used are the light shelves. While doing simulations, we understood that the light which is far away inside into the workspaces is a little below 200 lux. Thus, we decided to provide light shelves which provide light deeper into the working spaces. This strategy provides three key benefits. improved natural daylighting, visual comfort, and energy saving. To optimize this system, we have provided the digital addressable lighting system, which was addressed earlier. This smart lighting system provides individual zonal comfort, two-way digital communication, supports up to 64 devices per loop, and a seamless integration with occupancy sensors. Together, this forms a responsive lighting ecosystem. Now, let's look at the building envelope, specifically the wall assembly. We have used 200 mm thick pulverized fly ash hollow soil blocks with bagasse insulation in place of regular burnt bricks. Our experiment showed that in 1 hour, the internal heat gain in case of regular bricks is 4.4 degrees, and in case of PFA hollow soil blocks, the internal gain rise was only 0.9 degrees Celsius. Thus, the proposed wall dramatically increases the time lag of heat transfer without increasing the thickness of wall. Moving further to the HVAC, the HVAC strategy is carefully tailored for seasonal variation. For the months of March to June, the direct evaporative cooling with light dehumidification system is used. From the month of July to October, indirect evaporative cooling and dehumidification systems are used, whereas for the months of November to February, indirect evaporative cooling, direct evaporative cooling, and VRV systems are used. With vertical green open spaces, terraces, and inviting recreational spaces, we provide a moment of pause, reflection, and connection. These elements aren't just beautiful, but they provide the much needed mental well-being and a relief from the workday pressure.
Coming to the energy performance of the building, our target EPI was 73 and achieved is 69.47. Here are the particulars for energy consumption of our building, wherein the consumption is 6,25,256 kWh per year, and the solar panel generation is 6,56,713 kW per hour per year, making our building energy net positive. For the energy generation, we depend on solar panels as our site is inadequate for wind energy generation. Here, in order to enhance and meet our consumption requirement, we conducted experiments wherein we compared a normal solar panel with a solar panel which had reflectors. With the use of this method, we saw a 12.5% increase in the solar energy generation. Further, to meet our requirements, we also used a solar tracking mechanism which helped us in increasing the total generation by 25%. In order to reduce the heat gain, we have used slit windows with light shelves. We have used a wall integrated water tank which helps in regulating indoor temperature while reducing the load on HVAC. At the same time, we have used colored glass which helps in maximizing the interior daylight while reducing the heat gain. In order to reduce the energy consumption needs, we have used PFA blocks which reduces the energy consumption by 7.38%. At the same time, we use DALI integrated lighting system which reduces the lighting load by 50%. We used a 3-stage hybrid cooling system which reduces the HVAC load by 64.89%. And with this, we conclude that with the using following strategies, we serve and satisfy our energy needs by 105%, leaving us with a backup of 18.37 days per year.
Water performance. Our first move was to reduce the water consumption at source. We carefully analyzed where the water is being used: drinking, pantry, evaporative cooling, irrigation, etc. And hence, then we carry forward and redesign the strategies accordingly. We used aerators and low flow fixtures so that the tap water is getting controlled. We use sensor faucets so that we understand and the water flows only when needed. We use waterless urinals which eliminates water completely in the male restroom. By using some of these strategies, our reduction was from 45 LPCD to 20 LPCD with 55.5% reduction with no compromise in human comfort. Step 2 was closing the loop. Why did we do this? Was because we wanted to treat, reuse and store the water. And hence, we analyzed that where the water is being sourced, where the water is being filtered, storage, uses, and treatment accordingly. So this is our main source. So for the source, we have a rainwater harvesting tank, which stores from the hardscape, landscape areas, and which collects to 21.5 liters. With we are only taking 6.12% from the municipal supply, which is used for sensitive purposes like pantry and drinking. When it comes to treated grey water, we are filtering it. The treatment is done from moving bed biofilm reactor, which the treated water is storing up to 35.4 lakh liters. And storing ahead, the rainwater harvesting tank is going into the wall integrated water tanks. And the municipal water is getting stored into the UGT, which is used for sensitive purposes only. So this is the figure explaining where the water is being flowed. And the water consumption is 6,070.86 meter cubes, and the water generation is 56,973 meter cubes, which brings up to 93.87% net zero water building. So when it comes to embodied carbon, what is embodied carbon? Embodied carbon is something which is done from day one. That is right from the extraction phase to the construction phase. So we have analyzed the base case and the proposed case accordingly. We have, for the base case, we have country fired brick, and we have proposed it with PFA hollow soil blocks. Emission from the wall is 72.3% reduction, same as with going ahead with the roof, floors, fenestration, structural, and the grand total emission is 46.2% reduction.
To truly achieve net zero, it is not just enough to look into energy consumption, but also the life cycle of materials. We have deliberately made choices of using materials which are low maintenance and which can be degraded or recycled further once the building is demolished. So these materials are good to go for 15 years, and after demolition, the materials can be reused or can be biodegraded. Next, we have also provided sprinklers, hose reels, extinguishers, fire escape staircases, and fire alarm systems to ensure occupant safety during fire hazards.
We Team Gen Zero had set our boundaries from day one. We knew that we have to give back more than what we take. So according to this, what the user needs, the user needs a prime location. So we have chosen the prime location in Kharari, which instills a sense of pride and purpose to the people using this space. It also lowers the energy bills with improved air quality, and also the stepped building with green terraces caters to people, like if the people are working out inside there, they can come and have their breaks, which is the need of an hour now in an office building. When it comes to partner, what does the partner actually need? Partner actually needs that the cost gets lowered. So we have used some technologies where the costs are getting reduced.
Initially, our goal was to limit the total capital expenditure to 10%, and we have successfully achieved it by limiting it to 4%. The rise in capital cost is attributed to the incorporation of PFA stabilized soil blocks with bagasse for external walls, BMS system, solar PV installations, STP units, and other related components. Capital expenditure increase is limited to 4%. This has a 4.7 years of payback period, achieved through electricity bill savings from the solar panels. Hence, Zenith Co-Works goes for a realistic approach to sustainability. Thank you so much.
Thank you, Team Gen Zero. Your team did a great job. So now let's hear the jury's comments and take questions from them. Dheeraj, I'll start with you.
Interesting presentation, frankly speaking, and found it different as compared to what I read in the report, to be honest. Comprehensively covered my questions which I had asked are also getting covered in this. So frankly speaking, I've got no other question than what I had asked during the report. I like the concept around air conditioning because you have put in some mind in terms of how do we further bring it down, both with respect to passive and active approach. Thank you. Appreciate it.
Yeah, similar comments. I think there is a lot of thought that has gone into the project. I really like the form. Very interesting. The step form, the way you chose where it needs to be, thinking about shading, the passive strategies that you've looked into, the creation of those outdoor spaces. Very thoughtful. Uh, so I think overall a very good design. I think you're going in the right direction, and I really appreciate the work that you've put together. Uh, there's a little bit of thought you should still kind of like progress and look together. I think I've made some comments on the report. So strategies, the thought in the strategies are very good. I think a little more evaluation on that will help you in in your thought process and like when you're getting into the actual things. But overall, a very good presentation and a very good report. Thank you.
Thank you, Sandeep.
Thank you,
Thank you, Dheeraj. Sangeeta, your turn now.
Yeah. So very good presentation. First of all, you all finished in time. Your time management was excellent. Something I have to learn from you guys. And you also had a collaborative, approach. Each one of you had divided what you want to speak. So that came across very well. And what I also liked is, the way you shaded the building. It looks very nice and, helps in energy and whatever else you said. Only one thing, once when you start practicing, your students, I understand, but you will also need to learn to, analyze spaces for equipment, because I guess that was not part of this competition, but it is a need of the hour, because unless you plan spaces for all the equipments, the spaces don't work. Overall, very good. And one more thing which I liked in your presentation was you mentioned about the end of life of the building and how the materials can be reused and they are biodegradable. So overall, very good. Thank you very much.
Thank you, ma'am. Thank you.
Thank you, Sangeeta.
Thank you.
Thank you.
Thank you so much.
Our second presentation is from Team Samarpan. They have worked on a project called as Garud in Mangaluru. They are representing their vision of soaring high with innovation and efficiency in transport infrastructure. So team, welcome on stage. So team, you will have 20 minutes to present your work. At 15 minutes, I'll ring a signal like this. After that, you will have 5 minutes, but you won't have a 21st minute, okay? So at 21st minute, I'll ask you to stop, okay? Then we will start with the Q&A sessions for 10 minutes. So please keep your answers direct and to the point.
Yes.
Okay, team. So now the stage is yours. Your time starts now.
So good morning, everyone. Good morning, jurors. We are Team Samarpan from Manipal School of Architecture and Planning. We are a group of individuals who have been focusing on sustainability as a main topic to bring change in this world. And myself, Chirant, I'm the team lead, and they are my co-presenters, Pratyaksha, Mukund, and Pooja. Now, sustainability is a global trend across all sectors, and it's a necessity at this era. And it also contributes, the building sector contributes 40% of the total energy. So it is a necessity to bring in change in this sector. So what about India? India, there have been implementations such as Net Zero by 2070, National Action Plan for Climate Change. With such things, our India has the largest number of green building projects going on. But they're majorly concentrated in private sector. The government, this is the situation. So our approach was to bring in change in public domain so that a public sector, public building could inspire the commoners towards the sustainability. And our team is divided with this goal into energy team, statistic team, and an engineering operation team who contribute to the core design team. Our project Garud, located in Mangalore, which is a warm and humid climate, and our project is basically a transportation hub happening in Mangalore, which has a depot space, a terminal space, and is considered supposed to be built in PPP project. This is the location. And moving forward, this is the context map, contextual map of showing the delegated site and its proximities to other KSRTC infrastructure. And our client had some specific needs, special needs such as a multiplex, so that revenue generation would be possible, multiplex, a convention hall, and Yatri Niwas for the stayers. And there were some more of these special requirements. We have noted down our stakeholders, the public users and the office workers. And we have divided the whole spatial organization into 3 parts. That is the office space, the commercial space, and the terminal area. And we have noted down all the visitors coming to that area. Now with all these considerations and requirement for our project, we selected 3 case studies. That is the present existing KSRTC bus station. Then we have the Kerala KSRTC Thiruvananthapuram, which is a recently constructed building. Then we have a secondary case study, an abroad case study, and we selected our factors, design factors such as form, spatial arrangement, wind analysis, so that we could quantify the case studies accordingly. Moving on to architecture. As an architecture, we had to focus on the cultural and traditional spatial organization of a locality to understand the climate. So we started with the Chavdi and Hebbagilu concept, where the commercial, the more public area, was taken in correlation to the Hebbagilu, and the Chavdi, which is a private area, was connected with the office area, and we started our process. Then we ran multiple simulations on CFD, solar shadow analysis, and also radiation analysis and daylight potential to come up with a final design. Then, since it's a transit project, we had to give major consideration into connectivity and road networking. So our main road is at a different level, and our site is gradually sloping and very flat. So we created a scenario for the bus to have a multi-level bus terminal, which also increased the capacity of the bus terminal. And they ramp down into the site and they move into the courtyard kind of thing getting created in the center for the terminal. That is the main terminal, and we have a secondary terminal. And finally, we integrated all the renewable and other other strategies to increase our energy performance. This is the created master plan. So here we can detailedly see how the depot and the main terminal are segregated and where the terminal are getting placed and the ramp placement and all the other details. Moving forward, this is our render, what we could achieve. And zoning. So as the ground floor is an open floor plan, majorly having only public spaces and entry points for all the division we had, the commercial space, the office space, and all the other spaces. The first floor, our building is actually segregated in, we don't have like a strict division of spaces in terms of vertically. We have it horizontally so that each space has something going on in each floor. So to have proper core services and all the other consideration. And it is represented here. Finally, in this pie chart, we are representing how much of the space is gone for office spaces, commercial spaces, meeting rooms, multiplexes. And since we are focusing on office space, passive office spaces, we have incorporated a exploded view on how the circulation is going on in each floor. These are floor plans, the other two floor plans, the second floor and the first floor plan, where you can see how the spaces are segregated and where are the spaces going on. We have detailed out the office area for the to show the KSRTC, how the spaces, KSRTC spaces are getting divided. Coming to services, the first diagram shows the AHU unit, the electrical unit placements in blue, the focused areas. Then we have the vertical circulation placed approximately so that every section of our building has a proper vertical circulation. Then finally, we have the washroom placements shown in this diagram. This is a section showing different, like the positioning of different elements in sectional view, the office section and the site section. These are the strategies we have incorporated. We have double layered glass atrium on the top, which acts as a solar chimney concept. Then we have jali walls, green facade, central courtyard, which starts from the first floor of the office, whereas in the terminal space, we don't have them. Like it's a open floor plan, there's no courtyard situation, atrium situation happening there. It starts from the office space. Then we have a double skin facade, which helps us in achieving some of the major energy performances. And we're gonna be talking about it in the energy performance. And finally, to sum up all the architectural things, we have put up some simulations here showing that from the existing building, we have achieved better daylight, better shadow analysis, and even better radiation. This is the view from the terminal. Now moving on to energy engineering and operations.
So speaking about engineering and operations, we initially started off by exploring the StatPro software to come up with a basic structural model. And then once we achieved the basic structural framework, we put it through a stress deflection analysis to understand critical areas. And based on these critical areas, we understood where the reinforcement could be placed. Speaking about the construction methodology, we plan to start with excavation and laying of the mat foundation, followed by erection of columns. Once that is done, we plan to incorporate mushroom columns on the terminal level for visual appeal. The third phase involves framework completion and atrium formation, followed by facade completion and laying of the double skin facade. Speaking about lighting, so we started with segregating the floor plans in separate functional zones, and we did an analysis of each zone based on the movement pattern of the users as well as the use of each space. We also noticed that there was a varying nighttime user pattern, and that's why we came up with nighttime lighting strategies to ensure energy conservation without compromising on safety and function during the nighttime. These levels mentioned are based from ECBC and NBC standards. Yeah. Moving on to the HVAC design. We did our research and we thought of coming up with a bar graph to compare the electrical consumption from each HVAC system. And we also came up with a Sankey chart explaining how different cooling methods, active, hybrid, and passive, are selected based on energy efficiency control needs and match to their specific building functions. Based on our analysis, we thought of proposing a VRF system, and this is the ducting layout for the same. These diagrams depict the VRF system and the split AC with fan system and the fans systems on different levels, and all the justifications are mentioned in the table. Again, this is a justification for load calculation for each of the aspects considered under engineering and operations. Moving on to this slide, it illustrates the operational flow of users across all the levels, which is segregated. The movement is segregated within KSRTC employees, travelers, as well as visitors who visit the commercial area. On the right-hand side, our service master plan ensures a efficient distribution of utilities across the site. Then, upon the jurors' feedback, we have also incorporated the BESS, which is the battery energy storage system, in case of any outages. And we've also incorporated the 4Cs for real-time monitoring and maintenance. Speaking about resilience, our design builds resilience across site level, structural level, and user level. The permeable surfaces, green buffers, as well as smart roads help us combat flooding, heat, as well as pollution. Yeah, that's all for the resistance part. Thank you.
Moving on to the building performance. So we conducted a thermal comfort analysis of the office space, the office block. So for that, we divided the office space into 3 different zones, and from the analysis we found that we were able to achieve a significant increase in the total percentage of comfort hours throughout the year. This we achieved by incorporating a combination of passive design strategies such as stack effect, cross ventilation, and solar chimney. The CFD diagrams, they show us that they show us how the form helps the wind flow in the exterior of the building at the site level and above the terminal levels, as well as how the solar chimney helps in increasing the wind flow and ventilation in the interior spaces. Moving on to the light analysis of the design. From our initial analysis, we found that 60% of the spaces experienced discomforting glare for more than 5% of the time annually. We were able to reduce that to a comfortable 15% annually through different strategies such as optimizing the envelope, double skin facade, and glare reduction. Also, we were able to reduce the lux levels from 2300 to 900 using strategies while still maintaining the minimum required by the standards, minimum lighting required by the standards. Moving on to the EPI optimization or the energy performance of the building, we were able to achieve an EPI of 53.90 kilowatt hours per square meter per year, while reducing the cooling load and the total discomfort hours. This can be seen in the graph right here. And we were able to reduce the EPI through an iterative process in which we took the base case and we optimized the shading and glazing. We used a double skin facade. Then we optimized the envelope of the building by changing the wall assemblies, roof assemblies, and window assembly to a lower U value materials. We used BEE compliant star rated appliances in our building to reduce the equipment load and the lighting load as well. And finally, we used an HVAC, a VRF-based HVAC system to reduce the cooling load of the building. So overall, we were able to achieve a total of 61% reduction in total EPI compared to the base case, which helped us achieve and meet the standards of building performance of the major standards. Then we also incorporated solar panels to achieve net zero in our building, and to push towards net positive, we have a suggestive wind turbine system, which with 34% catch efficiency and 45% system efficiency, which can help us achieve that net positive and move beyond net zero. Coming to the embodied carbon, we incorporated strategies such as in situ construction, carbon negative and low carbon materials such as agrocrete, GGBS concrete. We also reduced the carbon emissions through transport by sourcing 90 to 95% of the materials locally. And we used curing methods as well to further decrease the total embodied carbon of the system. We decided to repurpose and reuse all the construction waste which we are getting from the previous construction on the site. So we are using concrete, laterite, timber, steel, and glass throughout the project in landscaping and in the building itself. And through all these strategies, we were able to achieve a total of 80% reduction in the total embodied carbon of the building, with 98% reduction in the walls through agrocrete, and rest through structural GGBS concrete and using better fenestration and reusage.
Coming to water performance, so we have focused on achieving net zero water performance. So this is the water balance chart, which mainly focuses on the strategies that we have used. Those are the 3 R's: reduce, recycle, and recharge. So when it comes to reduction, we have reduced 50% of the total daily consumption per person by using all the alternative fixtures. And Zerodar being one of the major contributors, it is a waterless urinal technology by Ecom. And this diagram here shows the sectional flow chart of all the water system that we have used in our project, starting from the sprinkler system to tanks, their capacities, the positioning, the levels at which they are placed, and so on, and what all activities it could be used for as well. And now, when we come to the second R, that is recycle, we are making use of STP by Ecom, which works on the principle of MBBR. And when it comes to the third R, that is recharge, we are making use of permeable concrete pavements, bioswales, and recharge pits. And in order to cope up with certain water issues like seepage of water into sensitive building areas like basements, we have made use of geotextile, as well as in order to avoid the contamination of the recharged water, we are making use of photocatalytic coating concrete. And here we come to the end of building performance. Now moving on to the most interesting part, innovation and collaboration. Our innovation is moss cotta, which is basically an amalgamation of moss and terracotta, which helps in air purification, aesthetics, it's durable, it helps in capturing the carbon, and so on. And when it comes to implementation, of moss cotta in our building, we have analyzed the wind movement and the patterns and aligned or tilted the moss cotta in certain angles, and the CFD analysis shows its efficiency. And these are our industry partners and their innovative collaboration. We have collaborated with Green Jams for agrocrete, Saltec for upcycling of deconstruction waste, Panache for cool roof on waterproofing paints, Coolant for Aeroleaf, Ecom for Zerodar, and GridMats for IoT technologies. And these are all the benefits mentioned aligning with the SDI contest. And now coming to the most important part of our project, affordability and value. The total cost, the estimated cost of construction is 30 crore 59 lakhs 84,000. And this is the life cycle cost analysis, which is basically a comparison between the conventional strategies OPEX and sustainable strategies OPEX. And the chart clearly shows that the sustainable strategies that we have proposed is much better than the conventional ones. And when it comes to cost reduction strategies, we have made use of the best of 9 strategies, and hence we have achieved 2.3% of capex reduction and 43.2% of annual OPEX reduction savings.
Coming to additional revenue generation on site in the building, we have noted down all the generation streams we have created in the project, and also the carbon credits. Because of the carbon reduction what we are doing and the green facades what we are having carbon capture happening, which also contributes to our earnings. And in this sheet, we have like summarized the whole affordability here, the total generation of cash from different streams, how much we have like rentals, carbon credits, and annual OPEX. Then we have the payback period, how are we achieving this in 8 years. And then finally, we have the estimated construction time. Since it's around 12 to 14 months, this is a reduction time when the investor has to invest his money, dead money there for the construction. The value proposition, we offer high water performance, reduced construction time and cost, user-centric design, and low energy consumption. These are the pitches what would be giving to the project partners, and which would regard for a higher value for an investor. Then stakeholders such as public users and all, we have increased employment opportunity and a good environment for them to work with a better facilities and clean environment to live. Coming to the question I started, why does the government sector lack private investment? Majorly because of the lack of maintenance, outdated design, low ROI, and limited revenue innovation. So this project, what we are proposing, would like bring in these changes so that the investor brings in more confidence into a government project, so it to be a sustainable green project, helping in bringing a lot of change, inspiring the public to move towards the sustainable practices in their day-to-day life, in their normal residential projects. That is how India could achieve that net zero in 2070. Our project, if for GRIA rating and IGBC, could achieve gold rating and a 4-star rating in GRIA. And we are passing on the pamphlets which are telling about all the benefits of all the contests and what we have achieved in all of them to show. This is our render.
Thank you, team. You have delivered really well. So now let's hear the jury's comments and take questions from them. Sandeep, I'll start with you.
Yeah, so overall a great presentation. There were a few things that I really liked. You got into the the specifics of certain things, the good qualitative, quantitative analysis. You knew what your metrics were. You were looking at all of those things, and actually presenting it in a very thoughtful manner, easy to understand manner. So kudos to that. There were certain things that really caught my eye. One of those for the innovation that you've done, that was good, and the carbon credits that you're thinking of, trying to look at ways to earn revenue rather than the regular mainstream things. That was a good insight. I think overall good design. And just one quick question. So the BESS system that you discussed about, if somebody can explain why you integrated it. I understand it was a comment, the BESS system.
Yeah, it's in terms of if there is a power shortage, or we are planning to incorporate it with the power PV solar system, so that if there's an excess energy flow, then the BESS system can handle it, and then the operation becomes smooth.
Yeah, thank you, Sandeep. Dheeraj, over to you.
Thank you, Dhanashree. A good thorough thought process behind the presentation. See, presenting on a public platform is never easy. I could see that coordination worked well for all of you. A few points which I noted down wherein you really did well was, frankly speaking, the points were well explained, well thought through and well explained. That's one. Standards reference on the electrical designing, what you did, is important. And if you have thought through that and then implemented it, makes sense about it. Affordability, the explanation, the working, the ROI, and why, how. I feel of all these things, how is the most important aspect. When you say that I'll do this, this is the benefit, how. You have answered those how is where I find the difference clearly. Only thing which I want to add is, Mukund, you spoke about the active and the passive strategies when it came to the air conditioning solutions. See,
Yeah.
Nothing for or against kinds, okay? This is my job to also help you understand what worked for you. You said that choosing of a technology reduce the heat, the loads. No technology ever reduces the load. Heat load reduction can only be done through passive strategies. The architectural design, what you do, the orientation, what you do. The technology which you use for air conditioning or any other thing can help you reduce the operating load, operating cost, how you use your system. So that's the difference between the two. So what work you do in the initial stage is so important that it can really bring down the loads and help us in achieving those net zero, what we want to achieve through this program. Not just through this program, but tomorrow, you all sitting here in this room are tomorrow's architects. And you have to be cognizant of this fact. That's all my job is to do. Thank you.
Thank you, sir.
Thank you, Dheeraj. Sangeeta, over to you.
So the first concept, first of all, well done. Okay. So you began your presentation by, talking about the traditional approach. So India is known, for the traditional, our past history. So I like that. Then you've also, taken up the cause of turning a public space green, which is a need of the hour. So not only, it also helps people to understand, the normal people. That is one point I liked in your presentation. Then in your water presentation about the water, you showed positioning of water consumption, the system components. So that was very well thought of. And I liked your innovation on, the facade. So overall, very good. Sure, why not?
Facade will be angled according to the simulation value at what angle they are supposed to be, and then they will be locked at that angle, so that the wind is not interrupted due to the facade, and it goes through the facade so that it reduces like the carbon going into the building is reduced through filtration process, like moss, through the moss.
This has to be kept wet, right? The moss has to be kept wet for it to go.
No, in Mangalore conditions, it is a natural process. We'll be just using the irrigation process so that it doesn't dry up. So when there is continuous hot summers during the summer, there are possibilities that they can dry up. But natural humid climate of the Mangalore is like it grows moss by itself on terracotta tiles. If you go like when we see the Mangalore terracotta tiles roofed houses, they normally have moss growth on them. So we are using the natural process and enhancing them with our strategy so that moss is healthy and it helps us reduce pollution, like carbon, whatever is going into the building.
So my question is, how do you ensure that only moss goes and not something else like fungus and stuff like that? Because if there is a moist space, just think about it.
Yes, ma'am. Yes, ma'am. So we have thought about it. So there is a research paper, and we have a QR code there also. So we have put our research papers there. So in that research paper, it tells about, it doesn't say exactly about the terracotta thing, but it talks about the moss being implemented in facade and how it is maintained and stuff. And also we have incorporated those strategies here because we have not done research particularly on this, but we have used research on different things to back our things and all the products and all, like how they work.
Sure, well done.
When are you starting the work?
So they are very interested, sir, actually. That's helped us to move forward. Also, the KSRTC Mangalore is actually interested to implement the project. But definitely under the guidance of some other architect, this is done completely by students. We didn't have any industry architect helping us pull it off.
Thank you.
Very good.
The world is so hot, hot, hot. We're making it cool, cool, cool. We're from SDI, net zero through and through. The world is so hot, hot, hot. We're making it cool, cool, cool. We're from SDI, net zero through and through, through. The world is so hot, hot, hot. We're making it cool, cool, cool. We're from SDI, net zero through and through. The world is so hot, hot, hot. We're making it cool, cool, cool. We're from SDI, net zero through and through, through. The world is so hot, hot, hot. We're making it cool, cool, cool. We're from SDI, net zero through and through. The world is so hot, hot, hot. We're making it cool, cool, cool. We're from SDI, net zero through and through, through. The world is so hot, hot, hot. We're making it cool, cool, cool. We're from SDI, net zero through and through. The world is so hot, hot, hot. We're making it cool, cool, cool. We're from SDI, net zero through and through, through. is so hot, hot, hot. We're making it cool, cool, cool. We're from SDI, net zero through and through. The world is so hot, hot, hot. We're making it cool, cool, cool. We're from SDI, net zero through and through, through. The world is so hot, hot, hot. We're making it cool, cool, cool. We're from SDI, net zero through and through. The world is so hot, hot, hot. We're making it cool, cool, cool. We're from SDI, net zero through and through, through. The world is so hot, hot, hot. We're making it cool, cool, cool. We're from SDI, net zero through and through. The world is so hot, hot, hot. We're making it cool, cool, cool. We're from SDI, net zero through and through, through. world is so hot, we're making it cool, cool, cool. We're from SDI, net zero through and through. The world is so hot, hot, hot. We're making it cool, cool, cool. We're from SDI, net zero through and through, through. The world is so hot, hot, hot. We're making it cool, cool, cool. We're from SDI, net zero through and through. The world is so hot, hot, hot. We're making it cool, cool, cool. We're from SDI, net zero through and through, through.
Hi everyone. Welcome back to the presentations of the office building division. Our third presentation will be from team V15. They have worked on a project in Panchayat Samiti office, which is located in Vasai in Mumbai. So it will be interesting to see the net zero energy, water, resilience and affordable solutions that the students are going to propose and the innovation that it will be resulting from. So welcome team V15, the stage is yours. So team, you will have 20 minutes to present your work. Okay. At 15 minutes, I will ring a signal like this. Post that, you will have 5 minutes. So overall 20 minutes, you won't have a 21st minute. Okay. After that, we will have a 10 minutes for a Q&A session. Please keep your answers direct and to the point. Okay. Team, all the best. You may start now.
Good morning, everyone. Esteemed jury members and everyone present over here. We are team 15 with our faculty lead, Professor Naina Raut, and industrial partner, Himanshu Satwi. In the Palghar region, there are 8 talukas, and we have focused on the Vasai Taluka Panchayat Samiti building. The next one. This is the region where it is near the creek in the Naigaon region in the Vasai West. The building name is Panchayat Samiti Office Building, where we have agricultural, educational, and welfare program offices. Here the site is around 4,350 square meters. Permissible built-up area was around 6,800, and the proposed built-up area was 2,850 square meters. These are the goals and strategies in which we have tried to cover everything which were given by the SDI team. So these are the goals and strategies. Here we have like given the entrance foyer where the spaces are open and
We have incorporated green spaces into the foyer, and this is not just a building, but it also blends the workspace and nature together. Later, incorporating solar panels on the southern facade, natural light and ventilation in the office is a crucial for energy efficiency, and the corridors are also wide. Passive strategies are thermal mass effect, roof insulation and heat reduction, rainwater harvesting integration. The building is a three-story building where we have incorporated and projected cantilevers. The building is oriented in east-west direction, so the north facade is already shaded, and the east and the west direction have staircase and passages, whereas the southern facade has dense vegetation, which also makes it happen that when winds are coming, the vegetation can make it pass like a cool air, and it goes into the building.
This is our site plan where the building is at the forefront from the road, and there are other buildings which are existing like residential quarters and the godown. We have basically planned it in the forefront, as we have like used vegetation like xeriscape. Even the local fruit bearing plants and flower bearing plants, shrubs and herbs.
We have divided the building into such a manner that the ground floor consists of the admin and offices. The first floor plan consists of cafeteria and semi-public spaces. The third floor the second and the third floor plan consist of offices.
So this was about the architectural design of the building. Of any building, if we look onto the architectural design, it's not just that. We have to look on to the energy performance, because that is what's functional in the long run. So here I'm presenting the energy performance. Our aim was to produce more energy locally than we source from the energy grids itself. So making it a net zero building. Next, we have actually it's a small Gram Panchayat building. Therefore, there are many different headquarters, many different offices that it caters to. And it's not an AC building, it's a non-AC building. So therefore, we have put consideration into the wall-window ratio, because it should be ventilated throughout. And the building being near to the coastline, because Vasai is a town which is a coastal region town. So we get a lot of winds, and because of the vegetation there, it's cool breezes. So we have made sure that we take advantage of that. Now this is the baseline design which was proposed to us, which was given to us by our industrial partner. We have made quite a few changes that would talk about in the further slides, like material changes to be exact. This is the load calculation that we have derived. Any building, a basic building that functions well, has three major loads, which is the lighting, ventilation, and the equipment load. Further to that, there are pumps. And then we have also added to 10% of an unaccounted load calculation that is miscellaneous. That could be anything of that sort in a building. Our EPI, which was the base through the baseline design proposal, our EPI was 38, and then we worked on through different strategies that we had discussed further, and now our new EPI is reduced to 60%. The strategies being solar PV. Solar panels are because of the ample amount of sunlight that we get. So we have placed solar on the roof panel, and we have many cantilevers as well in the building. So we have incorporated urban landscape, urban farming, and solar panels over there also. A second thing is if it's a Panchayat Samiti building, so there is it's a public building. You can call it a semi-public building as well. So there is the footfall is greater. So we have placed paver tiles in the entrances and also in the corridor spaces, so that when people are moving, that movement produces energy, and that could be used later on.
Water performance focuses on optimizing water usage and managing resources efficiently. As per NB's NBC 2017, the domestic water demand for an office building is 45 liters, and our office building has an occupancy of 470 occupants, which makes it a 6.6 million liters usage of water annually. To improve water performance, we have implemented efficient fixtures to reduce daily consumption from 45 liters LPD to 30 liters per person. Key interventions include water pressure regulators, low flow fixtures, and flush fixtures. This has resulted in an 33% reduction in annual water consumption. For landscaping and irrigation, for landscape irrigation, considering Vasai's coastal tropical climate, we calculated water need for softscape for an area of 2000 square meter using drip irrigation, which saves around 45% over a traditional method. The daily requirement reduces from around 40%. To further enhance water performances, we designed a rainwater harvesting utilizing rooftop, softscape and hardscape areas with an average and annual rainfall of 266 mm. The total catchment area is 2100 square meter, can collect approximately 5 lakh cubic meters of water. As a part of our water performance strategies, black water is treated on site using sequential batch reactors, processing 85% of black water, which generates around 10,000 liters of water per day. The diagram illustrates integrated water management cycle for rainwater, is SBR and other treatment plants.
We have used CSEB, which is compressed stabilized earth blocks, which are eco-friendly and durable. They are also locally available and require less cement and mortar than traditional bricks. Solar energy conservation and solar energy generation are also incorporated. BIPV, which is Building Integrated Photovoltaics, Urban Planning, and Solar Rooftop Panels. We have also incorporated urban farming with list of native shrubs and plant species. This is how the building integrated photovoltaic solar facades can indeed be used on the roof.
Coming to the thermal comfort of the building, as we spoke earlier, the orientation of the building was according to the thermal comfort, and also the vegetation in the south provides a naturally cooled air. Still, we have considered the IMAC model of Indian neutral temperature that that is for the naturally ventilated buildings. For cases like ours, it's a humid climate. Therefore, according to the seasons, it could be more humid as well. So we have used dehumidifiers in case, and also there's a big assembly hall which can see cantilevered over the last floor on the third floor. So for that, it's a big hall. So therefore, we have used cuss curtain fins that regulate the airflow of the area. These are the passive shading strategies like open assembly spaces, the passive shading that is going on to the entrance, and therefore how we have used canopies and cantilevers to shade the rest of the building.
Embodied carbon refers to the total generation of gas emissions, greenhouse gas emissions generated during the transportation, extraction and transportation and installation of building material. A comparison of baseline and proposed materials was done during carbon embodied tool for 1 square meter functional area. The proposed case achieved a total 65% reduction in embodied carbon emission. The major reductions were seen in walls, roofs, floor, fenestrations and structures, building structures. The reduction was achieved by introducing compressed stabilized earth blocks for walls, reducing emissions and energy use, filler slabs and RCC slabs, lowering concrete construction, and UPVC windows offering better insulation, UV resistance, and lower embodied carbon. Total emissions was reduced from 1300 to 453 kg.
RCC framework is used to prevent earthquakes, high wind speed, and passive shading is used for high temperature. The key idea is to manage water scarcity and heavy rain by using drought resistant plants and use of materials to allow rain to soak into the ground.
Going on to the project summary, our partners had provided us a rough estimate because it's a government project. The Gram Panchayat Samiti was a government project. So there was a rough estimate that was provided to us, but because of use of some baseline materials, our estimate is gone on to a little bit higher from the expected tender. But there is because of the materials that are sustainable, so it justifies the slight overall increase. This is a basic bifurcation on what construction costs are, increased.
The intangible aspects are work culture, its perception, some sort of comfort and safety. The environmental and social impacts are that it helps local community and also reduces environmental harm, saves energy and cleans air, and also focuses on natural light and ventilation spaces.
I would like to conclude that in a world where architecture often chases skylines, we choose to look closer to the ground, into the heart of our village. And rather than designing a sleek corporate tower, we focused on a humble but powerful building, a Panchayat Samiti office. Thank you.
Thank you, Team V15. That was a very insightful presentation. Now we'll hear the jury comments and take questions from them. So, Sangeeta, I'll start with you.
So in one of your slides, I saw that you had put the solar panels in an incline. So you're using it on the vertical surface. So sometimes it happens that, space on the roof is not available. So I thought that it was quite an innovative thought because it also provides some shading, so it's a two-way thing. So that's something that I liked. Only feedback I wanted to give you at the end, you mentioned that, the cost of the project exceeded the target that you were given. So what normally happens in real life is you have to explain to the client that you have a payback, so you have to do that analysis and show a total cost of ownership and tell them that the extra amount is justified because you will get it back within a certain frame of time. So that's how it has to be explained. Otherwise, well done. Thank you.
Thank you, Sangeeta. Sandeep, over to you.
Yeah, I think overall good design. I think the architect, so you explained something about the collaboration, you got the design. So can you explain a little bit more about?
Sir, actually, the architect, the industrial partner we are talking about, Stira Architects, was into the designing process of the Gram Panchayat Samiti. And when we looked onto the competition for an office building, we didn't want a skyscraper. We wanted something that was very unique and that was very touched. Because if I go on to tell you about the vision of the architect, this Gram Panchayat building is rules 31 villages of there, and it is going to be an example for the 31 villages over there, and they have a scheme to build houses under that scheme of the Gram Panchayat. So that structure would be an example for that houses, because whenever we see a structure, we see case studies, but whenever we see something in real life, it touches that's a different connection. So that if we have a sustainable building like this in the village community itself, people will get inspired and build their houses. So this was a vision. So the design is based on that principles. We have designed the design of the building along with the industrial partner.
can one of you kind of point out what was the design elements or features that you influenced the architect? So there was some initial process that it seems like from what I
Yes, sir,
understand,
yes.
there was
Yeah.
some initial design process and a thought process, which is really great and really appreciate, their intent and their ideas. I would like to understand from you, what was your additional inputs after your analysis that you felt enhanced the architectural design that was there?
Sir, the design that was actually there was what it would be like a common office. When we spoke to the industrial partners, we talked about how we can introduce like architectural things like cantilevers, because it's a small office, so no one really thinks about the design. It's just the purpose of the building, and there's a tender that's given, and there are specific requirements like this much rooms or this much. So no one really thinks about the design. So when we intervened, so we suggested that we could maybe like, it's a G+3 structure, it's a minimal building, so maybe we can add little bit cantilevers or the design things that we have, like smaller windows. We have double gaze windows. The assembly hall is put on the top rather than on the bottom. So minor changes that we could make, because it's towards a tender, so we could not really change much, but we could add in our small inputs to the case.
So yeah, overall, really like the way the architectural design come through, the entrance, like how you thought about that. Systems kind of integration was like, okay. I think like overall you've done a good job, and it seems like you were more aligned towards how it was going to happen, because that the phase it was in, you felt like you were held back with the tender process and all that. But I think in a design competition you should feel more free. Maybe one last question, because we still have a little bit of time on your own clock. What was one thing that maybe another person on the team can take this question? What was that one thing that you felt you could do if you were not constrained by the initial design, or the fact that it's like been through some tender process? What would you have done like totally differently?
Sir, actually, we have already incorporated a lot of cantilevers and courtyards as well, and there are a lot of vegetation around the site. So, what we thought initially was to like make it look like it's not just a normal building where people can come and just do their work. It should also look like something pleasing for people to come and get their things done, because it's a panchayat samiti office. And that is the only thought that came into our mind at first, because we wanted to redesign this building because it already exists there, and we wanted to make this for the people. So there was this one thought that we have to make it like green spaces and stuff for the people.
Do I have some time?
Yeah, you do.
Thank you.
Thank you so
I want to
much.
speak about three things. Okay. One is what Sandeep actually brought out is a right thing. Okay. Looks like that all of you became pretty defensive when it came to a gram panchayat design and limitations. The limitations were probably bearing heavily on your mind and overwhelming for you to think very differently and overwhelmingly. Innovatively. On that only, I'll say that keep your mind open. Don't get yourself restricted, because as he rightly said, you are in a competition and you are supposed to give your best to the client as well. So think that way. And when you have to think that way, the only example I can give you is there was a team last year on the same platform who won the grand jury award. And you know what they did? What did they design? A police station. So if they can get it, you can also get it. Think that way. So I will still urge, in order to see what more can be done without limiting yourself, just have a look at that report also. And third is good work done on the waterfront. I mean, you have done so much of detailing. If you could think so much about water, why not on other aspects also? Why to limit yourself? You didn't limit yourself when it came to water, right? So why not others? Energy, I saw you said it's a non-air conditioned building, but I see a load on air conditioning is also there.
Sir, we have provided a provision, but it's not an AC. We have provided split AC, so it's a provision, not an AC building.
Okay, good. But good effort done. Don't limit yourself is what my suggestion will be. Thank you.
Thank you. Thank you, Dheeraj. Thank you, Team V15. Now let's take 5 minutes and get ready for the next presentation. Hi everyone. So now our fourth presentation is from team NaMiti. They have worked on an office project which is located in Airoli, Navi Mumbai. They are striving for a vision to create an office building that fosters elaboration, collaboration, and sustainability together. So welcome on stage team NaMiti.
Hello.
Team, you will have 20 minutes to present your work to the jury. At 15 minutes, I'll ring a bell like this. Okay? So you won't have a 21st minute, which means at 20 minutes, I'll stop you and ask you to end your presentation. After that, we'll get time for 10 minutes Q&A from the jury members. All right? All the best, and the stage is yours. Thank you.
Good morning to all. We are the students of VESCO. Introducing our team, NaMiti, I, myself, team lead Shravani Raut, and my team members Yukti Bande, Samiksha Kothavle, Anurag Utekar, Om Marana, Divyansh, and our engineer Siddharth Soel. This project is undertaken with the project partner of Team 1 Architects and our client Reliable Spaces. Our site is located in the Airoli, Navi Mumbai, which is behind the Mindspace area, the IT commercial hub. Our client wants to develop a pharmaceutical office building with a leasing each floor to the various companies. Our most interesting feature of our site is the Pasik Hill behind our site, which gives them panoramic view for the users. Our site spans 3,585 square meter with the permissible ground coverage of 40% and 4.5 FSI. As access to our site is the MIDC 30-meter wide MIDC road. Next. Considering Navi Mumbai climate, it is warm and humid. We have done climatic analysis to enhance the user comfort. The temperature ranges during the summer is 35 degrees Celsius, which is solar radiation on the east and west facade, even the south facade. The highest rainfall in the month of July is the 1800 mm. The prevailing winds during the monsoon season, which are from the direction from west and southwest, and the rest of the months, the prevailing winds are from the west and northwest, which next. So the ground floor as the reception areas, admin offices, meeting rooms, and the cafeteria. And the backside area we have provided parking. As the site has 3-meter hard rock under the ground, so we have provided podium parkings, 3 floors, and another 8 floors are the office buildings and laboratories for various companies for use. Our design evolves to the 4 stages. Initially, we started with the solid mass. As our site is very constrained, so we started with the solid mass. Then we focuses on the solar radiation, like self-shading building and wind gaining. So for self-shading, we introduce the projections on the west facade and the south facade, which reduces the heat gain. Initially, we provided voids in the west and southwest facade, but later during the monsoon season, the winds come with the rains. So that's why we shifted our voids towards the north and northwest facade. So the recent latest stage of building is the all projections on the west facade, east facade, and south facade mainly, and voids on the northwest, so it gets the prevailing winds and get the capturing the winds with the Venturi effect, and also giving the self shading towards the south facade. Also, the building spaces is divided into 3 components. Like the ground floor is the common spaces areas like reception and cafeterias. The backside area is the parking. The 3 floors are the still parking and podium parking. Here the building is divided into two stages, two sets of floor. Two sets of floors. So first sets of floor, those are the voids. The voids are increasing by the each floor and giving us the breakout spaces for user to have relaxed and calm spaces over there. And another three sets, the voids get shifted and reciprocate to the another side on the northeast. Next. These are the site plan. So the entrance is from the front gate, and front is the common spaces, I said, cafeteria, and back is the parking. And so our middle core, because of our projections and voids, we have created a middle core to be stronger. So we have kept the staircases, toilets, and the shafts which are needed for the laboratory spaces in the central. So it can divide it equally in the both side offices. Also gets a maximum strength for the projections which are cantilevered. Next. These are the views from the, this is how actual building looks like, and the entrance from those.
So talking about the passive strategies, words have been given on the southwest and northeast facades to enhance the ventilation and reduce energy loads, and the projections have been given on the southern facade to minimize the heat gain and to protect the projections from the heat gain. We have given a double skin facade, which is which are the fins.
The double skin facade is a movable fence. As the sun keeps moving, we can operate by the user. The initial on-off buttons is inside.
You can continue the presentation.
Yeah, I'll show it later.
Yeah, yeah.
So it has the two switches, forward and the backward movement. As the user sits, and if they are getting glare from the outside from the facade, they can easily operate those two buttons by clicking them, and this first fence will be moved. And as per their angle and as per their comfortness, they can set those facade. Yeah. Dusra button. Yeah, this is how the facade moves.
Yeah, so for the health and well-being, so these two simulations show the daylight which is maximum on the edges of the building. So we have provided the laboratory spaces and office spaces to the edges so that we can get maximum daylight inside. And according to the simulations of Vayu Pravaha, we understood that the maximum wind is from west side. So we have also try to keep the offices and the voids to that direction so that we can get maximum wind inside. And to improve the indoor quality, we have provided indoor plants such as golden pathos, rubber plants, snake plant, and spider plants. And for the mental and social well-being, we have tried to give breakout spaces, which are the voids for the employees, landscaping, and we have tried to create the layout of the office space in such a way that every employee can communicate to each other, which creates a more communication between them. So talking about the energy performance, according to the SDI, the benchmark for the energy is 67 kilowatt hours per square meter per year, where we have achieved 56.89 kilowatt hours, which is a huge reduction. And we have given high efficiency solar panels, 335 solar panels on the roof, which generates 4,82,400 kilowatt hours of energy. And the extra energy which is generated during the off days is transferred to the grid so that it is wasted and can be used whenever emergencies are. Yeah, so for wall we have used aerogel plasters and AAC blocks, which creates insulation and reduces heat transfer. Roof, we have provided green roof, which reduces heat transfer from the roof and and improves thermal comfort in hot climates. For windows, we have used argon gas filled gap and reflective glass to reduce heat transfer and solar gain, leading to improved energy efficiency and better indoor comfort. Yeah, so for the grid, we have used grid interactive efficient buildings, which will enable smart energy exchange with the grid and exports the so next HVAC system. We have used water cooled chilled water system, which uses chilled water from a chiller to cool indoor air via HUs. The water absorbs heat and transfers it to the chiller to cool again, and the absorbed heat is transferred to the condenser water loop and reject and via a cooling tower. This cycle repeats in continuation. So the for water, according to the NBC standards, around 45 liters is required for office building, and we have reduced it to 17 liters, which is a reduction of 62%. Talking in numbers, it is 78,840 liters per day, which is reduced to 30,000 liters. We have tried to replace the conventional fixtures to touchless faucets, dual flush systems, aerators, and even waterless urinals, which aren't just water efficient, they also enhance hygiene and user comfort. Every year, our building generates around 4.66 millions of liters of grey water, and instead of letting it go to waste, we filter 85% of it, which is nearly 4 million liters, using membrane bioreactor system. This clean filtered water is reused for flushing and cooling, eliminating fresh water. Also, we have treated our black water with an anaerobic baffled reactor. Out of 8.3 lakh liters, around 6.25 lakh liters is treated and reused, and the byproduct sludge is converted into the compost for landscaping. Our HVAC system operates only 10 hours a day, which keeps the annual water requirement to 2.68 million liters, and for that we have tried to use the filtered grey water. Next.
For innovation, we focused on reducing manual effect in everyday life. Collaborating with industry partner Nevino Automation, we developed Water Drop, a sensor-based water motor system. The smart system monitors the water level in a tank and automatically switches the motor on or off, depending on whether the tank is empty or full. Water Drop not only provides real-time water level measurements, but also ensures easy installation, user-friendly operation, and even includes advanced features like remote monitoring. In embodied carbon, materials such as China mosaic tiles, slag wool insulation, and green roofing AC block for walling helps in 74% of reduction in carbon footprint, supporting industry target for achieving net zero emission, leading to a more sustainable and efficient construction process.
Yeah, about the resilience in our project, it goes beyond surviving disruptions. Yeah, for that we have integrated rainwater system harvesting, retaining walls, and percolation pits. Also, green cover, AAC blocks, and orientation has been the countering for the urban heat island effect. Also, for fire evacuation routes have been there for the safety of the building, and yeah, projected slabs, double skin facades, and green roofs have been there for the thermal comfort. Solar panels and natural ventilation, which acts functionally, ensures functionality. About the project narration, it bodes a step towards the sustainable and net zero architecture with 85% reduction in energy. Also, it delivers a net zero water performance and cuts carbon footprint by 74%. For clients, it is a future-ready investment delivering about 82.68% energy offset, with a total cost of 112 crores and construction cost of 67,097 rupees. It achieves 87.3% of baseline cost. This basically, this basically all the aspects. This basically all the aspects demonstrate that high performance sustainable design can be economically viable without compromising on quality or functionality. Thank you.
The transformation of Airoli is inevitable, but how we shape it, that still is in our hands. Crystal Towers stand as proof we can build future without burying the planet. Thank you.
Thank you, team. Good job done. Now we'll hear the jury comments and take questions from them. Sandeep, I'll start with you.
I think the overall presentation went well. The initial work that you did in terms of understanding and working the architectural massing, that was quite interesting to see, how you adapted a thought that you had based on site conditions and had to, retain it, but then still, move it around. And so, I think one of the things I would say is invest a little bit more time in understanding some of these concepts a little bit more, ingrain it yourself so that it comes out a little bit more naturally. And I think overall a good work. One of the things, one quick question. So you talked about water drop and those things. Trying to understand the industry collaboration, how did it impact on the sustainability side of things, right? If you could, somebody could highlight on, what the industry collaboration was and how it impacted on sustainability or any of those aspects.
So actually we thought of something which will reduce manual work. So we just asked them that can we make some machinery which will based on sensor, it should be like sensor based. Usually water motor is manual. We need to close it and on it by our hands, but this is sensor based. This will automatically get off when the water is full and on when it needed more.
Also, sometimes it is seen like there can be overflow of the water and the water can be waste. We don't want to waste that water. That's why we put it the sensor, so it can automatically get off, so it doesn't get any wastage of water over there.
I got a couple of questions. One is around technology. You mentioned that you use the chilled water system for cooling. You did a lot of detailing in terms of your load requirements, etc., and you decided that you will go with a water cooled system. I did not see the connect from the heat loads to the choice of equipment. How did you arrive at that, and what is the efficiency of the equipment you picked up, relating it to the standards and the labeling program we have today? Did you do some work around it, or how did you reach that conclusion, if you can help me understand?
Just 2 seconds.
Uh,
It's okay.
uh, for HV system, we thought it is a laboratory space, so it needs air conditioned. So the rest of them we saw, which are most high energy efficient. So the lowest we found is the air water chill system. Also, there is a very dust around there, so it needs for purification also inside the uh, environment. So those HV system works in terms of that also.
I appreciate the detailing you did. Okay, I take your answer also.
Yeah.
Now, as I said to the previous team also, our responsibility sitting here is also to guide you what more can be done. What is it that can help your project something more than what you have already done. See, when you as architects design a building and get to the detailing, you have done the hard work of doing the heat loads. That's the toughest job, to arrive at that conclusion that this is the load requirement. After that, it's a choice of technology and why that technology. That's a relatively easier job. What it does is, when you try and gain awareness around technology and related benefits, the task for you connecting to the MEP consultants and discussing with the end user also becomes much easier. That why are you pushing for something when you are asking that this is the best thing for you? So focus or give more time during your studies on technology developments as well. That will help you become a better designer, architect, and a better solution provider to your user. So that was one. Second was, I also want to know, uh, building automation systems. Did you work around it, or you touched upon that briefly? I remember in one of the answers what he asked from a building automation perspective, or during your slide presentation, somewhere you touched it. But how much of that encapsulates the complete building as a whole from a services aspect, so that it renders the operational efficiency? Am I able to make you understand my question?
Actually not.
See, the building will become more efficient by using building automation system. You said you are using it,
Yeah.
right? In some of the aspects like water, you're using sensors. So is it on parts only you've used, or you've used a complete building automation system for entire facility? Or you used in parts as of now?
For water, which sensor we are talking about, that is for entire of the building.
Okay.
And other sensors, which are these facades and other technologies, is all entire for the building. So every floor, which are various companies, they can have easy access for their floors and connect with them.
So you have used every service separately. You have not brought all those services together on a common platform.
Actually, the services on the mainly in the laboratory office are the ducts, the gas shaft, and the data influent. Those are the entire for the building, which are connected to the shafts, and also the plumbing and the water provide connection. All the connected to all over the building, not separately.
Understood. Point taken. Thank you.
So I'll just repeat what Dheeraj said, that one of our roles over here is also to act as a guide. So first of all, I must compliment you. I really love that, and especially to see that working, and the concept of where as a user I should be able to change my vision of what I'm seeing outside. I love that.
Thank you.
Okay, but there were a few things which I felt were missing. So you've designed this building as an office building. You mentioned that there is also going to be lab spaces.
Yeah.
So the requirement of a lab is completely different, which I did not find, in your presentation, because everything in terms of energy, in terms of air, in terms of water. When I was going through your presentation earlier, you've mentioned ETP, that you are providing ETP because that labs use chemicals, so the water cannot be drained just like that. It has to be passed through an ETP, which is there in your presentation, which you didn't highlight today. That was an important element. Then even as far as fire is concerned, there are chemicals which are hazardous in nature. So the fire management has to be done differently, as far as a lab building is concerned. And the same goes for the cooling, because again, there are concepts of cleanliness in a lab. There are concepts of pressurization. you know. So though your thermal load and everything, which he said is very good, just that element, you know, because you have to, when you talk about any application of a building, you have to understand what is the building used for, and you have to tweak your design to suit that. You know, you will need more fresh air to come into the space. You will need extract air. So your building also needs to take into account those requirements. Otherwise, overall, a good presentation. Thank you.
Thank you, ma'am.
Thank you, jury members. Thank you, team NaMiti. So now we will take a long break for lunch. We will start the presentation for Team Arasa at 2:30 p.m. Folks online, I request you to tune back to this channel and be ready for the presentation of the upcoming teams. Thank you.
Solar decathlon, India, what's it all about? Net zero building, what's that all about? Solar decathlon, India, what's it all about? Net zero building, what's that all about? Is it cool? Is it hot? Is it drool? Is it fat? What's that all about? Real world problems need innovative solutions. If you don't act now, there will be implications. Is it hot? Is it cool? Global warming would be cruel. You will form a team with the same desire. Going for the moonshot, forged by fire. We use technologies and crazy simulations. We learn to design with new innovations. So what you waiting for? No procrastination. Get off your butt, come join our workstation. Solar decathlon, India, what's it all about? Net zero building, what's that all about? These problems are tough and complex too. Your partners are there to help you get through. This challenge is exhausting, intense, it's a drill. These 10 mad contests will sharpen your skills. Net zero energy, water and stuff. And affordable too, that's crazy enough. Solar decathlon, and yeah, heck, it's really tough. But your attitude and grit is more than enough. Get your hands dirty on real world projects. You're gonna learn more than your specialized subjects. Solar decathlon, India, what's it all about? Net zero building, what's that all about? Cutting edge, butting edge, climate wedge, make a pledge. Do it all, save it for a lonely planet after all. Understand, climate friend, take a stand, make a trend. In the end, recommend your ideas will help defend. Are you hot? Are you cool? Are you gonna be a fool? Zero heroes are here to stay. So what you waiting for? Come join this play. Net zero building, that's what it's about. Solar decathlon, India, that's what it's about. SDI.
Pick a site on a railway track. Put your building on an earthquake crack. Cutting million trees and planting roads and houses with their electrical loads. Dumb ways to build, so many dumb ways to build. Dumb ways to build, so many dumb ways to build. Put your building facing west. Make a toast of every guest. Concrete, steel, here and there. Carbon emissions to poison the air. Dumb ways to build, so many dumb ways to build. Dumb ways to build, so many dumb ways to build. Forget to put a bathroom drain. Add handrails that cause you pain. Elevator shafts that taper down. Bad staircase trip over your gown. Dumb ways to build, so many dumb ways to build. Dumb ways to build, so many dumb ways to build. Start building with no hard hat. Walk barefoot, toes go splat. No gloves on, no goggles too. I wonder what these wires do. Dumb ways to build, so many dumb ways to build. letting all your rainwater run down the drain. Heat the earth enough to fry eggs on the sidewalk. With homes that must have ACs always running. These mistakes we make are all avoidable. And that is why we must let go of these dumb ways to build. Dumb ways to build. Dumb ways to build. So many dumb ways to build.
Build less, build smart. A message from Solar Decathlon India.
The world is so hot, hot, hot. We're making it cool, cool, cool. We're from SDI, net zero through and through. The world is so hot, hot, hot. We're making it cool, cool, cool. We're from SDI, net zero through and through. so hot, hot, hot. We're making it cool, cool, cool. We're from SDI, net zero through and through. The world is so hot, hot, hot. We're making it cool, cool, cool. We're from SDI, net zero through and through, through. so hot, hot, hot. We're making it cool, cool, cool. We're from SDI, net zero through and through. The world is so hot, hot, hot. We're making it cool, cool, cool. We're from SDI, net zero through and through, through. hot, hot, hot. We're making it cool, cool, cool. We're from SDI, net zero through and through. The world is so hot, hot, hot. We're making it cool, cool, cool. We're from SDI, net zero through and through, through.
on time, and I'll be taking this very seriously.
Enhancing the occupant's comfort. The DALI-based lighting system is a sensor-based lighting system wherein a DALI sensor is attached to the lighting system. Was closing the loop. Why did we do this? Was because we wanted to treat, reuse, and store the water. And
Coming to the thermal comfort of the building, as we spoke earlier, the orientation of the building was Hello, everyone. Welcome back to the office building division. We will now continue with our presentations. Our fifth presentation is from Team Arasa. They have worked on a commercial center located at Baner, Pune. We all are excited to see what this team has done to showcase their efforts on striving towards net zero energy, water resilience, and more. So team, welcome on stage. So team, you will have 20 minutes to present your work to the jury. At 15 minutes, I'll ring a signal like this. You won't have the 21st minute, which means at 20th minute, I will ask you to stop and end your presentation. After that, for 10 minutes, we will have a Q&A sessions from the jury members. Okay, please keep your answers direct and to the point. Okay, all the best team.
Your time starts now.
Hi, this is Team Arasa.
Uh, okay, team, your time starts now.
Hi, this is Team Arasa from Vivekanand College of Architecture and Engineering from Mumbai. So, from starting person. Hi, good afternoon. This is Team Arasa from Vivekanand College of Architecture and Engineering from Mumbai. So here we present to you our office building. Our site is located in Baner, Pune district in Maharashtra, which experiences a warm and a humid climate with intensifying urban island effect. So basically, uh, this urban condition brings rising discomfort, compromised air quality, and growing environmental stress. Along with it, it also faces seasonal waterlogging, inefficient waste treatment, and lack of mental stress, which further complicate the urban experience. So, we, a team of 7 students from architecture and engineering, along with our faculty members, rethink on what an urban space can be. Our project aims and reimagines the urban offices to be biophilic, energy conscious, and human-centric environmental design. So, by blending nature along with innovation, our projects aim to foster productivity and prioritization of holistic well-being. Our project partner, with the goal of sustainability, our project partner did not have any specific requirements, except that the offices are supposed to go for rental. So the open floor plans with minimal divisions were required. Site context. So our site is located in Baner, Pune district in Maharashtra, which is just beside the Mumbai-Pune National Highway. Also, the linear site is surrounded by service roads on all the 4 sides with a dimension of 270 by 32 meters. Also with an area of 8,000 square meters. Additionally, the longer edge is along the east-west direction, hence benefiting the design by reducing the radiations towards the west. Also, our site is located in a residential zone. So, it is surrounded by the residential buildings and only a few commercial buildings are along the way. Also, the site has a gradual slope of 1 meter, which acts as a natural drainage. Pune experiences a warm and humid climate with hot summers, distinct monsoons, and mild winters. So, the temperature ranges from 9 degrees Celsius in the winters to 40 degrees Celsius in the summers, with distinct variations, hence making night flushing very effective. High solar radiations requires effective shading, hence by using the Andrew Marsh, we calculated the overhangs.
Coming to the design process, with limited exploration on the ground floor, we decided to play in the vertical zoning. Keeping in mind the 5 elements of the nature, we focused on natural methods. The design alterations were done on the basis of voids and open spaces. Through simulations, we realized that uh, dif- uh, dividing the mass into 3 different blocks helped us in self-shading, and also uh, helped us in the creating the recreational spaces. The zoning consists mainly of 4 parts: the retail spaces on the ground floor, podium parking on the above floors, and office spaces above them with the terrace, including the recreational spaces. Looking at the planning of spaces, the ground floor is dedicated mainly for the retail spaces, which helped in increasing the interaction with the shaded open spaces. The structure in the surrounding helped us to provide a shade in the open outdoor spaces throughout the daytime. The recreational spaces are divided such that the outer access was only limited to the shops, and the separate entrance were provided for the above office spaces. Vehicular movement was restricted only to the north side in order to increase the human interaction without interruption. The above 4 floors were dedicated for podium parking. Instead of basement, we preferred podium parking as the hard strata was only at the depth of 4 meters. Podium parking is naturally ventilated and shaded with green facade. Service floor is being designed between the podium floor and office spaces. The office spaces are further divided into 3 different types: large office spaces, small and medium. With reference to NBC, considering the travel distance, core areas are being placed in the center of the block, so it divides the office zonings. Lobby spaces are naturally ventilated with cross ventilation. At regular intervals, recreational and refuge spaces were designed. The width being the 18 meters minimum helped in acquiring the natural daylighting with reduced need of artificial lighting. The terrace area has been dedicated as for the recreational spaces during the office hours and also after the office hours. This helped in increasing the interaction and also reduced the heat gain due to green roof.
While choosing the materials, they were chosen based on the proximity to the site. After setting out and marking the site, isolated footing of 4 meter were given on the depth of were given on the hard strata. A structural grid of 11 meter by 11 meter along the longer side with waffle slab was provided to create a larger span. The walling material is made with AAC blocks with cellulose and fiberboard insulation and plastering. The west facade is used as a green facade to reduce heat gain. The longer facade, that is the southern facade, is covered with solar glass panels. The solar glass panels are provided in a gradation so as to give a visual effect while generating energy. The solar glass panels was done in partnership with the Solarscape, our industrial partner. The building management systems integrate energy monitoring, occupancy comfort, waste and water management. It includes providing occupancy detectors to manage lighting and HVAC. The HVAC system adopted for the office building was a chilled beam system with DOAS for a higher efficiency and a better indoor air quality. The chilled beam provides cools the spaces through natural convection, and the DOAS supplies filtered fresh air, ensuring comfort. We also created a platform called Go Green, which calculates where the employees can track their emissions by inputting their travel distance and the mode of travel. The users can also input their electricity bill, which calculates their emissions by the OCR method. There is a leaderboard method which decides the least amount of emissions. Those users get incentives in the retail spaces on the ground floor and the recreational areas. For the simulations, the minimum of 300 lux was ensured in the office spaces. For the using the Vayu Prava app, we ensured all these spaces, all the lobbies had a proper cross ventilation. Even the ground floor, the retail space was ensured enough daylight, and the direct solar radiation was reduced using 40% window to wall ratio. For the internal comfort, the CFD analysis was done to ensure there was a proper comfort inside, and the result showed about a 22 degrees Celsius temperature inside the office areas and the lobby spaces. The office spaces were air conditioned with fixed windows, whereas the lobbies were naturally ventilated.
Coming to the energy performance part, so keeping in mind the 71% of the EPI as our goal, considering 298 operational days with 8 working hours for office spaces and also 12 working hours for retail spaces, we brought down our base case EPI of 108 to 43 using strategies like form and orientation, envelope optimization, walling with a U value of 0.21 and window with SSGC of 0.22. We also reduced our window to wall ratio to 40%. For considering HVAC, we considered chill beam, which also helped in reducing the energy consumed by the HVAC. And passive strategy like night flush ventilation, which is more effective in a place like Pune, where the temperature difference is like slightly more during the night. And with efficient lighting, we reduced the EPI to 43. So our energy consumption, considering equipment loads, EV charging, mechanical loads and lighting, our total energy consumption was 17,10,600 kilowatt hour per year. And to reduce like to generate the energy on site, we with the help of on-site solar glass on the facade and the roof, we generated 19,80,400 kilowatt hour per year. This energy was passed into the grid and then again used by our building, so that like even if on the days where the energy generation on the site is less, we also have like we can collect that from the grid. Coming to the water performance part, 61.7% reduction was done from the base case to the proposed case by using efficient fixtures, and the daily water demand was for office users was 19 liters, for retail spaces it was 15, and for visitors it was 11. So we taking the water cycle, we took from municipal supply, we collected 66,000 liters per day for drinking, cooking and cleaning, and the grey water and black water collected on a site was further recycled, and 65,000 liters were recycled, which was used for flushing, HVAC and irrigation. For treating of the water, membrane bioreactor was used as a treatment. So it used various screenings which helped in reducing the wastage and also like filtering more amount of water, and it also uses less space as compared to other. And the sludge which was collected, which was then stored into a slush tank. The HVAC which we considered was chill beam system with 573 tonnage of cooling load was required for a building. So in chill beam, basically the like beams are attached, and then water is passed through the pipes, and then the warm heat inside the space is
is it taken inside through the inlet, and the coil around the pipe helps in cooling down the air and releasing the cool air. The with DOS, it helps in dehumidifying the space by supplying fresh air from the outside. Like it was done like with water chiller on the terrace spaces. Embodied carbon was reduced by 71%. Like for the base case we considered conventional materials like AAC, fiberboard, cement, and like which were available. But for the proposed case, we considered sandwich walls of AAC with insulation like cellulose, which was readily available within 20 kilometer of our site. So it helped us in reducing the embodied carbon emission by 71%. Coming to the resilience, Pune lies in seismic zone 3, so isolated footing was preferred, and also a hard strata was just as 4 meter. For firefighting, we chose mist-based sprinklers, which mist-based sprinklers. Also, for green facades helped in reducing the urban heat island effect around the site. Also, since the vehicular movement was reduced to only one side of our site, the other spaces on the ground level used a semi-permeable flooring, which helped in on-site drainage. Native plants were planted around the site so that it can increase biodiversity. Coming to the affordability, the total construction cost of a building was 54,000 per square meter, with the capex of 214 crores. We brought down the cost because we tried to do reduce the electricity required for energy by 100%, and also for water 39%, water usage 39% was reduced. The operational cost of a building is 2.5 crore. With our building also generates 100 crores because of energy and on-site renewable energy generated. Coming to the value proposition, considering two main stakeholders of our, like the user and the client. The user receives lower operational cost with comfort, and also smart and tech integrated spaces, which helps in easy accessibility. And coming to the client, since the site is located just beside the main Mumbai-Pune highway, it is a strategic location with easy connectivity. Being the return of investment of just 2.1 year, it helps in it reduces the return of investment, lower maintenance because the materials and the because of the material systems used. For concluding, our EPI was brought down to 43. We reduced water by 62%, with carbon emission reduced to 71%, and a return of investment being 2.1 years. So this was our part of a commitment to the building sustainable, resilient, and human-centric workspaces. While also we catered 8 SDG goals while designing our building, also considering the social, economic, and environmental factors for our building. Thank you.
Thank you, Team Arasa. You finished well within time. Good job. Now we'll hear the jury's comments and take questions from them. Sangeeta, I'll start with you.
I have a question for you. You said you're using chill water system. So what kind of chiller have you considered in your design?
The water chiller.
Yeah, but water chillers are also two kinds, air cooled and water cooled.
Yeah, water cooled chiller.
Okay. So one or two good things which I found in your design is that your building seems to be future ready because you've talked about EV charging. Okay, so automobile industry is moving in that direction, which means you have given a thought to this. Uh, Overall, good presentation.
Thank you.
Yeah, I think overall good presentation, and I think um, architecturally, like you mentioned, the site was a benefit for you, and I think you took advantage of that and did well with that. There were a couple of things that I wanted to kind of ask questions about. One, you mentioned about night flushing, and you mentioned in passing the temperature differences. Wasn't sure it was seasonal temperature difference or a diurnal temperature difference.
It was like during the daytime, the DOS system, which has a unit outside on the terrace, that system is only used for the night flushing, so that we can maintain the filtration of we can maintain the filter, we can filter the air from outside. And also that was because we saw ki the daytime temperature was around 30 to 30 degrees Celsius, but during night the temperature drops till 14 to 15 degrees Celsius. So like that air we can store somehow.
Yeah, how many days in a year that happens, and just think about it. It's a good thought, but just a little bit more focus on that. Uh, and then you mentioned about BIPV panels. Wasn't sure if it was just opaque panels or was it like translucent BIPV that you used on glass. Maybe an answer on that would be helpful.
Yeah, those were translucent VIPV panels. So our project partner Solarscape, they have designed almost transparent and based on the opacity different types of solar panels, which also helped us in aesthetic look of the building. Like rather than a plain facade of solar panels, we gave a gradation of red color or like any color, which was translucent panels.
With that, just a comment, make sure that because it's an office space, the lighting conditions in an office is very important. You can't have patterns on your desk surface or like just a consideration. And also, I think one of the things I noted was you mentioned about recycled content and recycled steel. If you could just elaborate on what was that recycled content that you were talking about, because I know you have a vendor and then you went to the vendor. I looked up their website too, so I just want to know from you guys what you were looking at when you were saying recycled steel.
So when we were considering the materials on the proximity of our site, there was a manufacturer who manufactured like recycled steel, which was used in some of the building for like construction. So we considered that steel for a reinforcement at some spaces. That was the recycled part.
Quite impressed with the use of technology in your entire thought process, whether it was with respect to the carbon emission app, or you mentioned about the Vayu Prava app which you used, or the CFD analysis which you have done to ensure the validation of your process, what you have done. I saw a complete systematic approach when I saw the energy performance index optimization as well. So quite impressed, and frankly speaking, I get to see a depth in your working, which is also reflecting in this Q&A what we are having right now with you. So that shows the passion what you have worked on. Few things as I have spoken with the earlier contestants also. Nothing to be taken away from the credit of the work which all of you have done. You mentioned about the water cool chiller being kept at the terrace.
Yeah.
Is that right?
Yeah.
It is right, but it happens only in exceptional cases when you do not get space in the basement to keep the water cooled chillers. So you'll have to recheck, because if you are designing a building, every inch of a space is very important for you, whether it is roof or basement, how many basements, etc. So normally water cooled chillers are kept in the basement.
Okay.
I'll say 9.8 times out of 10 times you'll find the basement. But that does not take away that they are also kept on rooftop in exceptional circumstances.
Okay.
A good job overall. Appreciate the work. Thank you.
Thank you, sir.
Thank you, Team Araska. Thank you, jury members. Now let's take 5 minutes and get ready for the next presentation. Hello, hi. Hi everyone. Now our sixth presentation is from team Ecoora. They have worked on a project called as Synergy Eco Park. It is located in Baner in Pune. So we are all excited to see what all strategies the team has incorporated with respect to net zero energy, water resilience, and so on. So team, welcome. The stage is yours.
Thank you.
So team, you will have 20 minutes to present your work to the jury. At 15 minutes, I'll ring a signal like this. Okay, post that you will have 5 more minutes to present your work. And on the 21st minute, I'll ask you to stop. Post that, we will have 10 minutes for Q&A sessions with the jury members. Okay, please keep your answers direct to the point and wishing you all the best. Your time starts now.
Good afternoon, everyone, and the jury members. We are Team Ecoora. I'm myself, Shreya. This is my team, Yash, Pritish, and Shubhi. We are honored to be presenting at Solar Decathlon Finals 2025. Our journey began with a shared vision to rethink commercial buildings as living ecosystems that regenerate the environment, enhance user well-being, and build stronger communities. With this in mind, we set out to design a human-centric high-performance building that addresses current environmental challenges while remaining adaptable for the future. This journey would not have been possible with the guidance of our industry partner, project partner, who helped us align to the goals, and invaluable support of our mentors and allied organizations. Synergy Eco Park is located in Baner, Pune, right beside the Mumbai-Satara highway with a direct access from Pashan Highway Service Road. The site spans 7,953 square meter with a total built-up area of 39,765 square meter. The site has a linear form stretching 270 meters in length with a wide of 42 meters on the east side and 35 meters on the west. It is bounded by a 12-meter wide road on the east and the west and 9-meter wide road on the north and the south. Located in one of the Pune's most sought-after commercial zones, Baner offers strategic connectivity, a thriving business ecosystem, and a robust infrastructure. The project is designed for commercial users with a total occupancy of 4,881 people. Retail spaces will operate for 12 hours daily and office spaces for 8 hours. Parking is planned for 640 cars and 1,500 two-wheelers. The requirement of our project partner is to follow build, own, lease model. Before coming to design, we did a thorough climate analysis. As Pune lies in warm and humid zone, through findings from bioclimatic chart, wind analysis through simulations, we have implemented various passive strategies to achieve comfort and reduce energy loads, and SunPath diagram to derive shading elements. Due to site's linear shape and height restrictions, the form of Synergy Eco Park was elevated, leaving the setbacks. It was then divided into 3 wings with a minimum 14-meter gap to allow ample light and ventilation. Following the NBC norms, cores were strategically placed on the south to reduce heat gain, enhancing thermal comfort. The roof of the wings are connected by a slab with cutouts, creating a shaded semi-open spaces below, while structurally tying the form together and allowing the light to filter into lower levels, creating the breakout spaces. As we arrive at the north side of the site, the ground floor welcomes users with a 3 dedicated drop-off point that lead to a lobby which is completely naturally ventilated with the use of fly ash jali. Opposite this is the road-facing retail frontage, which creates an active edge, enhancing walkability, offering vibrant commercial spaces. Cycling pods are placed at this level, promoting sustainable mobility. Native plantings along the pathways helps cools the environment and supports biodiversity. On the 5th floor, the amenity level is designed to promote health, collaboration, and well-being. It includes gym, a lounge for informal gathering, a banquet hall for events, and semi-open workspaces that brings people closer to nature. These spaces are surrounded by native landscaping, creating a calming environment. Passive design strategies are integrated across the building. On the north facade, the horizontal light shelf also functions as a chhajjas. On the east facade, the balconies act as a thermal buffer, and centrally located shaded semi-open outdoor spaces enhances ventilation. The west facade features a vertical green wall that reduces solar heat, filters air, and helps control noise from the surroundings.
Starting with the structural grade, we have adopted a flexible design using 7.5x 11 meter and 11x 11 meter grades. This allows us to support open offices and large banquet halls and premium offices. Both grades consider parking and optimize function and aesthetics per space need. Next, moving on to our building management system, it uses IoT-based controls for HVAC, lighting, and power. It actively monitors temperature, humidity, occupancy, and daylight, and makes automated adjustments for energy efficiency. Grid interactions, load storage are also integrated for smarter energy use. To ensure long-term sustainability, we perform regular water and energy audits. Monthly water metering and periodic audits help us keep track and identify inefficiencies. Our strategies align with GRIHA guidelines, with energy audits beginning 6 months after installation and continuing every 3 years thereafter. Moving on to the next slide of HVAC system, we have implemented a custom hybrid setup using a water-cooled chiller and IEC, indirect evaporative cooling. Our hybrid evacuation system combines combines with water chiller and IEC along with evapooler. IEC module pre-cools air without moisture or any and next, water-cooled chiller ensures comfort in humid environments. Smart control switch modes based on environment and occupancy. Moving on toward the next slide for waste management and commissioning. The waste management system handles 500 kg of organic waste, 600 kg of paper waste, 10 kg of e-waste on a daily basis, and it utilizes a 3R model, the reduce, reuse, and recycle, along with segregation into general waste, organic waste, paper waste, and e-waste. It falls under the UN Sustainable Development Rules 11 and 12. Moving on towards commissioning. It has 5 design phases: pre-design phase, design phase, construction phase, acceptance phase, and post-occupancy phase. In the design phase, we are appointed a certified green building consultant at project inception and allotting special rules. In the design phase, it holds regular and consultations with the commissioning agent to align the system with the rules, with the goals. In the construction phase, it documents all the construction, tests and verifies along with the system and goals. And in the post occupancy phase, it conducts ongoing monitoring again and again to ensure for long-term sustainability. Moving on towards collaborative innovation, at Synergy Eco Park, our approach to collaborative innovation brings together sustainable mobility, renewable energy, waste management, and community engagement. Starting with cycling pods and EV charging stations. First, we have introduced solar-powered EV charging, podium-level charges linked to rooftop solar, drawing zero grid energy. Next, cycling pods. Ground-level cycling pod facilities encourage employees and the wider community to choose green mobility. Also, adaptive transport hub and well-being boosts are used. Moving on towards the solar facade. So the solar facade, as the rooftop area was inefficient to meet the building's energy demand, we have introduced a solar effective solution using the solar facade at the south side of the building wall, which faces the south side. This long facade offered ample sunlight exposure, allowing to efficiently generate energy through a vertical solar installation and effectively supplementing our sustainability goals. Moving on towards the carpooling and waste management. Carpooling is promoted to reduce emissions. It is not just sharing a ride, it's a smart, sustainable solution that benefits individuals, businesses, and the environment. We'll talk about waste management or encouraging tree plantation drive in the next slide, where we have developed a web app for an all-in-one solution and information guidance in a single application. The web app named Synergy Eco Park to simplify and enhance the user experience by offering services like carpooling, security, and announcement. All-in-one platform. It features secure sign-up and login to protect user data. Carpooling reduces traffic emissions, while the security sections provide detailed floor rescue plans to ensure user safety during emergencies.
Indoor plants like areca and bamboo palm were selected for the ability to purify the air and lower temperature. About 30% of building area is naturally ventilated, while a 68% use HVAC, which is a hybrid system, water-cooled chiller system plus indirect evaporative cooling with MERV 13 filters. Our hybrid HVAC system supposed to maintain temperature between to 19.98 degrees Celsius and 26.9 degrees Celsius with humidity control at range of 42 degrees 60%, achieving over 90% annual comfort hours. Light levels range from 200 to 1000 lux with the 40% window wall ratio, achieving visual comfort without glare. We created the breakout spaces, a library, a gym, and a games room. All spaces are barrier free with ramps and universal toilets. We also provided areas for plantation drives, workshops, and community exhibition, enriching user connection with nature and community. Based on the calculation for the fixtures and equipment consumed, the energy for lighting load is 3.23 lakhs, and equipment load is 5.76 lakh, and cooling load is 8.85 kilowatt hour per year. These loads are efficiently reduced through the strategies such as using efficient fixtures, HVAC optimization, and high performance envelope design. We brought down the API down to the 44.9 kilowatt hour per square meter per year from 71 kilowatt hour per square meter per year. That is 33.76 drop from the target benchmark. The building wall section achieves the U value of 0.28 watt per meter square Kelvin using sandwich wall of AAC plus cellulose insulation plus AAC. The U value of roof reaches from 0.183 watt per meter square with the TPO membrane and insulation layers. Glazing uses DGU with 0.27 SGC and 40% VLT and blue tint for glare control, which is complying the super ECBC. The dual axis solar panels on rooftop covering of 60% of roof area, that is 2212 square meters, that at 580 WP per panel. This system offsets the most internal loads. The panels are angled to maximum generation throughout the year. On south facade, vertical BIPV panels are added, generating over 10.6 lakh kilowatt hour per year. Together with the rooftop generation and on facade, this makes the building net positive in terms of energy, generating more energy than it consumes. It is also grid interactive, exporting surplus to the city grid. The water consumption optimized using the aerators, vacuum flush, and waterless urinals. We reduced the daily use per person from 45 LPCD to 10.5 LPCD. The total water use dropped from the 2 lakh per day to 68,000 liter per day, a 66% reduction from the base case. The annually water treated is 1.09 crores of liter, 43 of black water and 49 liter of rainwater. Therefore, amount of treated water is more than the yearly water consumption by 0.5%. Thus, building is achieving net positive benchmark for water performance. This diagram represents the complete water cycle within the energy Synergy Eco Park, showing how water is used, treated, reused, and conserved. The water balance system collects the municipal and rainwater into UGT, which is pumped to the OST tanks used for drinking, cooking, and cleaning. Grey water treated is reused for flushing and landscape. Black water treated separately through the STP. Rainwater harvesting and filtration reduce demand, making the building net positive in water performance.
The project prioritizes reducing embodied carbon through the use of sustainable, locally sourced available material and low impact material. The key strategies include replacing traditional fire clay bricks with AAC blocks, using locally sourced RCC to minimize transport emissions, and applying gypsum plaster instead of cement plaster to reduce carbon intensity of finishes. While the innovation is the use of recycled cellulose insulation produced from post-consumer paper waste. While cellulose insulation is typically factory made, the process involves shredding paper, treating it with boric acid and borax for fire and pest resistance, drying to reduce moisture content, and fluffing the material for application. The insulation offers thermal resistance for approximately 3.5 per inches, making it comparable to conventional options like glass wool. It uses within cavity wall and roofing system to improve energy efficiency and indoor comfort. To meet the insulation needs of approximately 35 cubic meters, around 1400 kilograms of cellulose is required. About half of it can be generated from on-site packaging waste, while the remaining can be sourced from outside. Coming to the resilience, social resilience. During a pandemic, the building can enhance resilience by repurposing spaces like fitness area and banquet hall to isolation wards to ensure accessibility. Instead of traditional wet sprinklers, clean agent fire suppression system is being used for the office areas. They are preferred as they rapidly extinguishes fire without causing water damage. Utilizing substances like FM200 ensures quick and effective fire control to address Pune's intensive monsoon patterns and mitigate the risk of urban flooding. The building plinth is elevated 600 mm above the highest expected flood level to prevent water ingress during heavy rainfall. Walkways are designed with a slope 1%, directing surface runoff into the adjacent landscape to infiltration zones. To enhance emergency preparedness, each floor of the 3 office wings includes 1 meter square pantry, where 25 meters square for canned pantry stored area. The measures to take an office building design, including shear walls on the edges of the core and symmetrical patterns for the office buildings, uh, structures for symmetric resilience. The steel bracing system not only supports the green roof but also contributes the building overall seismic performance by adding stiffness to the roof structure. The project coming to the costing, the estimate of the project is 276.2 crores for the first year. It covers the entire cost of the building. It's a one-time expense, no capex required for the second year onwards. Coming to the OPEX, it is zero in the first year as the building will be under construction. It will gradually increase as the building becomes operational. Expected to reach approximately 13.5 crores by fifth year. Coming to the cost reduction strategies, to the designing part, we have designed spaces like the banquet hall and the retail shops. Renting out these spaces will create an additional revenue. And also the open floor plans, it will cut down the material and lightnings and the labor cost. Talking about the materials, AAC blocks and cellulose insulation has been used, which is eco-friendly and lightweight and cost-effective. Energy, facade with solar panels and high-performance material enables 100% electricity bill saving by generating clean energy. Talking about water, 66% is being reduced as talked earlier. And finance, through the rental income, average market rent of rupees 120 per square feet per month in Pune for office spaces. The project is expected to generate rupees 5 crore in monthly rental income, totaling to 61.68 crores annually. There's an operational saving of rupees 15 to 20 crore over 20 years with an upfront capital expenditure, capex, of 276.2 crores. The project is expected to earn 308 crore in rental revenue for over 5 years.
Moving on towards value proposition for end user. For end user, we have employees, businesses. Ecoora is designed to enhance comfort, boost productivity, and promote inclusivity. Following other features like ample daylight, excellent air quality, and vibrant speed, such as breakout spaces, game rooms, gyms, etc. These are some of the features for end users, such as smart infrastructure, sustainable design, net zero energy, user amenities. For project partners, the office, it offers a prime location, iconic design, and phased construction that ensures quicker execution and faster returns with just a modest 3.7% increase in upfront cost. We ensure 20 to 30% savings in long-term operations. The ROI potential is estimated at rupees.
Thank you, Team Ecoora.
Thank you.
You have delivered well. However, the time is up, and now okay. So let's move on to the jury members for question and answer session. So Sangeeta, I'll start with you.
So one of the things that I liked in your presentation is that you've talked about waste management and segregation of waste. So the world is dealing with a lot of problem, and segregation is the key to recycling. So that is something I liked about. But there are two comments which I have. So you mentioned about canned food as food storage. So now my question is that sustainable? Because canned food comes with an expiry date, right? So what is your thought process? I mean, first of all, it's not very healthy to have canned food, and then it comes with an expiry date. So I want you to think about it. Then in your last slide, you mentioned something about return on investment, and it's coming to about 10 to in over a period of 10 to 20 years. The client will get back some 50 to 60 crores. So in the real life world, that's too long. Clients want to look at a shorter max 2 to 3 years is what they look for. So that's maybe something food for thought for you and for improvement.
I think your presentation started out really well. I thought you were going to utilize your time very well, but in the end, I think you were a little bit over time. But that's fine. I think you covered most of the parts that you wanted to. A couple of things that I wanted to highlight was like I like the fact that you were looking at cycling pods and commute not just within your infrastructure but also looking at outside. I think that was something that was interesting. Like the fact that you're showing light shelves on the facade and in the details. When you talked about solar panels, you kind of knew where they were going to be and how they were working. Couple of things you did talk about in the BMS when you were showing that diagramming. You were talking about load monitoring and storage. You did also mention batteries, but didn't highlight that. I think good insight into why that is important when you have a lot of renewable energy production on site is something important. It's the hot topic right now. Did learn more about it. And I think the commissioning part also, I kind of like the fact that you're looking at commissioning, not just design of the systems, but also looking at commissioning has to start from day one, and trying to understand how the systems operations management also needs to happen. One question I would want to ask you is the cellulose insulation. Did you look into the term called LTTR, long-term thermal resistance? Because some insulation products, you gave me an R value or a resistance value, but over a period of time, maybe 1 year, maybe 5 years, depending on the material, the insulation properties will drop drastically, right? You're talking that it's a hot, humid kind of climate. I know it's sandwiched between AAC blocks. AAC blocks are kind of porous, right? Trying to do it on site. So those practical issues, long-term issues need to be looked into. Conceptually, it's great. I know, you got a lot of points from that in your embodied carbon calculations, and it's great, but you should look at the practical aspect of it. But I think overall, good presentation. I like the amenity space, like how you put your solar panels on top of those things. Explaining what you did is also important. Doing a lot of things is good, but explaining them, showing it is good. Thank you.
A good presentation, comprehensive one, frankly speaking. Impressed. What I liked about is health and well-being. You put a lot of focus around there. Your design strategies mixed with an IOQ approach and determining how much it is helping to the occupants of the building. The detailing is really well appreciated. That's not an easy work to be done, frankly speaking. Other than this, I also looked at the way you are looking at not only the BMS covers one aspect but multiple aspects. So you are restricting yourself to only monitoring. I'll encourage you to start thinking about, may not be for competition, but as a budding architect, you should start thinking now about how to monitor and then use the data to optimize the operations. That's the next level. See, if you are building, or if your building is meant for years to operate, how can that be a building which is a sustainable building without optimizing continuously? Start thinking that way. That will help you. One question only I have for you. I think I had put in my comments also earlier on. The chiller you have chosen, you said, is a 5.5 COP. Is that reflective of a 5-star AC? Chiller AC, I will say, or not? is my question to you. Okay, I get the answer, don't worry. Okay, don't worry. Please start reading about it. When I say that, it's important because a 5.5 COP will not reflect a 5-star. Okay, a 5.5 COP in a water-cooled system will at best reach about to 3-star. So you have an opportunity to further improve the efficiency of the building. That's what I had highlighted. So these are the areas, which make you a better person, a better designer. End of the day, when you go to the real field, the real world, the expectation is and will be, what value are you adding to the person who is paying you? Remember that. Thank you. Good work.
Thank you. Thank you, sir.
Would you like to explain a model for a minute?
This is actually the green wall which is on the west facade. So what we had done, the addition is that the user in the building can also water this plant even if it is outside. So the piping system which is there, with that will be connected to our window level. So the normal user, when he is leaving, when the water bottles are still filled with water, instead of wasting it, why not just put the water in? And so the central water is also saved, and the water which is going to waste is also saved. So that was the idea behind the green wall also.
Okay. Thank you.
Thank you.
Thank you, Team Ecoora. Thank you, jury members. Now let's take 5 minutes to get ready for the next presentation. So our last and final presentation is from team Ma Earth. They have worked on a project called as Maker House, and it is located in Kodambakam in Chennai. So team, welcome on stage, and the stage is yours now. Wish you all the best. So let's go through the rules once. You will get 20 minutes to present your work. Okay. At 15th minute, I'll ring a bell like this. Okay. Which means at 20th minutes, you won't have the 21st minute to go on. Okay. Post that, we will have a Q&A session with the jury members for 10 minutes. Please keep your answers direct to the point and wish you all the best. Okay. So team, your time starts now.
Greetings to the jurors. We are team Ma Earth, a group of 15 enthusiastic students across different disciplines in Chennai, brought together by a shared passion for design. Today's presentation will be delivered by the 4 of us, and we'll be starting off with the introduction, followed by the 10 contests, and then a conclusion. Before we begin, we'd like to share a small story. So like most days, the news were filled with headlines about environmental issues, heat waves, flooding, pollution. But that day, as news played in the background, Mr. Natarajan, a small business owner, sat thinking deeply. He had always dreamed of building his own office, a place that would help his business grow. But this time, alongside that dream, something else weighed on his mind: the responsibility we all have towards the environment. He didn't just want a building, he wanted a place that made sense to the future, a place that would help, that would reflect his values and be kinder to the planet. And that's how we met our client. Our conversations with him were not just about walls and rooms. It led us to ask a bigger question. Why are we doing this? Why should we take up this project? And that why became the start of our journey, and everything else was followed by it. Chennai is a coastal city with experiencing a warm and humid climate. In recent years, rapid urbanization has led to a significant rise in population and hence a growing demand for micro, small, mid-scale enterprises. Urban density, pollution, flooding, traffic congestion are some of the pressing issues that our city faces today. But then we thought to ourselves, these issues aren't unique to Chennai. They exist in most growing urban cities. So why be selfish in our thinking? Can we come up with a solution that addresses this bigger issue? As a team, we came up with multiple design ideas. By interlinking all these variables, we ended up with a common domain of a modular approach, a framework that could adapt and evolve in different contexts. A prototype. So a prototype need not always be a physical structure, but it can take shape through planning strategies, material choice, envelope design, construction techniques, and building operations. By combining all these, we ended up with the concept of plug and play, tailored to fit, built to shift. And that's Maker House. Our site is located in Kodambakam, Chennai, and has an area of 523 square meter. Client discussion gave us an understanding of the requirements, which were then translated into planning strategies such as staggering of levels, providing breakout spaces, and so on. Our client, Prime Source Technologies Private Limited, deals with premium quality computer-related accessories. A detailed building area program was derived with the goal of maximizing the area for a tight site for 48 users. Naturally ventilated spaces were maximized and air conditioning spaces were reduced to 22.4% of the total built up, which is 1048.5 square meter. Form generation. So the form was developed based on various decisions taken. For example, functional efficiency, providing green spaces, staggering of levels, reducing incident solar radiation and thermal load, of course keeping in mind the local regulations. The programs are zoned along the centrally paced core. We have our cabins along the eastern side and the assembly area on the workspaces on the western side. The logistics centers is zoned at the basement, while services and terrace garden occupy the topmost level. Site-based decisions were taken to restrict circulation, unloading and loading circulation, and the daily user circulation. So different entries are provided for the same, promoting use of public transport. We provide shuttle service in Maker House. On the first floor, recreational spaces are placed along with the assembly area. Manager cabins are zoned to the east and workspaces to the west. These are typical for the next 3 floor levels. The terrace level has a terrace garden with seating to increase collaboration between the users as well as provide a connect with nature.
Moving on, with reused materials, local skill, and a clear plan, Maker House grows from the ground. Based on the soil report, hard rock was found at 28 meter, and hence a raft foundation was suitable. Soil stabilization using lime and fly ash tripled its strength. Compressed stabilized earth blocks were made from on-site mud, and hence it reduced the embodied carbon emissions. Slanted RCC column reduced material usage by 25%. Conscious decisions were taken for the material usage to reduce embodied carbon emissions, and ground granulated blast furnace slag cement GGBS cuts 47% of CO2 emissions. The roof garden incorporates native varieties of plants with over a 200 mm slab. E-waste is managed responsibly through a dedicated system showing the building's social commitment. The 3D printed facade uses parametric modeling using Rhino and Grasshopper with Ladybug and Honeybee plugin. The facade is panelized into hexagonal divisions using the Lunchbox plugin. VWF, Variable Water Flow System, is opted as it reduces the refrigerant use by 75% and increases the cooling efficiency by 15% as compared to a VRF system. Water is used as the heat transfer medium. Its modular design ensures that continued operation sustains even if one fan coil unit fails, hence doubling its lifespan and reducing CO2 emissions. Thus, the VWF system reduces the cooling load by 32%. Recognizing that planning was just the start, we had to level up our creative game to bring in innovations to our design. We came up with a data-driven, customized facade for our design, which is tailored to our site conditions. Looking at different envelope options, a brick wall offers less ventilation and has lower views, while a glazed facade offers maximum views but has higher solar heat gain and has less ventilation, while a louvered facade would allow air to flow but blocks the views. So combining all the three, Radiant Hex was thus born. Our 3D printed facade is opted because each panel is unique and customized. Targeted facade modification led to a sharp reduction in solar radiation from 2300 to 200 Hz. The apertures vary according to the site data, and hence it increases ventilation through those gaps. The facade module is 3D printed in collaboration with Twasta manufacturers, and the structural integrity is tested through 3 different iterations. The facade section consists of an overall frame, which is steel, and stainless steel cables are created using a mesh, and each unit gets placed onto it. In collaboration with Auroville Earth Institute, our next innovation was born. Typically, this is how an MSME office workspace would look like. Should we blindly follow this trend? Introducing our vaulted ceiling, a self-supporting sustainable structure that offers a clean and smooth finish, enhancing indoor occupant comfort. The mud from the site improves thermal lag and reduces HVAC load. The services are concealed within the voids of the arch, and hence it provides a smooth finish. Clear-story windows aid in stack effect, helping maintaining cross ventilation. The earth from the site is excavated to make CSEB, which is used for the construction of the arch. Indigenous techniques and local labor from the neighborhood of Kodambakam is used for the construction as well. Our major challenge was to increase dependency on renewable sources in a tight site. So, reimagining rooftop thus emerged. Multiple efforts were taken to maximize our generation. So, first we placed solar panels on one side of the terrace, then increasing it to both the sides, and later elevating it to a height, providing a 13-degree angle according to Chennai's location, then adding small openings with bamboo screens to let in sunlight for the terrace garden below. Our solar slope was thus born. This innovation helped us reduce thermal load. Integrate vertical screen of creepers is cost effective and a centralized system maintaining clean and organized look. The number of panels is increased by 40% and the energy generation is increased by 66%.
As a responsible owner, Mr. Natarajan prioritizes occupants' well-being and comfort that has been achieved through strategies such as stack effect through courtyard, venturi effect through radiant hex, a terrace garden and a solar slope to reduce thermal load, and incorporation of indoor plants to improve air quality. Visual comfort has been addressed with the vaulted ceiling as mentioned earlier, diffuse lighting by the radiant hex system as mentioned earlier, which has significantly reduced glare and lower temperatures. The terrace garden also serves as a calming breakout space, thus connecting the users with nature. Ozone being the primary pollutant, we have incorporated low VOC materials, the use of activated carbon filters in our VWF system. The thermal comfort analysis shows that majority of the occupants felt thermally comfortable, thus satisfying ASHRAE 55 standards. The daylighting analysis confirmed that the required UDI levels have been achieved for over 90% operational hours. As we transition into the performance analysis, our key energy goals revolve around maximizing on-site energy generation, optimizing energy loads, all aligned to make a house working hours of 9 a.m. to 5 p.m. Monday to Friday. We dealt with energy performance in two aspects: the energy conservation method through active and passive strategies, and energy generation through a solar slope. Conservation was achieved through combination of passive strategies such as stack and venturi effect, cross ventilation, and the use of low U value materials, and active strategies such as the VWF system, regenerative drive in the lift, etc. The building envelope optimization was achieved by using radiant hex, the vaulted system, and the use of locally available materials. As we mentioned earlier, we have achieved thermal comfort and maintained uniform daylight illuminance, averaging 300 lux in most of the occupied spaces. As a result, the ambient lighting has been reduced to 2 to 4 hours a day, and the air conditioning load has been limited to the same. This has led to achievement of 33.1 as an EPI. On the energy generation front, the solar slope at this graph shows that the peak cooling load demand is 40.5 kilowatt during the month of May, for which 50 kilowatt of VWF system has been designed. On the energy generation front, the solar slope at Maker harnesses approximately 43,000 kilowatt hour annually. We have used a grid-tied system in which the energy generated from the solar slope is directly sent to the grid while generating revenue and simultaneously drawing energy. Chennai's significant water scarcity makes our water performance a testament to sustainable management, focusing on 75% of rainwater harvesting efficiency, the reuse of grey water, and a self-sufficient net positive water balance in addition to aeration and drainage. With the use of low-flow fixtures, we have reduced the water demand to 1,075 liters per day, which is a 53.7% reduction from baseline. This water balance flow chart shows the collection of rainwater, the treatment of grey water, the aeration of the stored water, and the various activities that happens in the building. This is the dual flow plumbing system that we have incorporated at our building. On a whole, at Maker House, we are at 70% net positive and with 21 days of autonomy. So, the grey water generation is approximately 500 liters per day, for which a root zone treatment of capacity 600 liters per day and with an efficiency of 85% has been designed. To improve the stored water quality, We have introduced a vortex aeration system inspired by Orable CSR. So this has contributed to aeration, odor control, and 95% pollutant reduction. We have also prioritized reducing embodied carbon across all building components. By reusing the soil excavated from our site and integrating low carbon materials like GGBS, Maker House achieves a remarkable 97% cut in embodied carbon. The switch from prefab and triple glazed glasses to CSEB bricks and vacuum insulated glasses has significantly reduced the embodied carbon emissions. The Sankey diagram shows major carbon contributions from structural and envelope components, which we effectively addressed using EAF steel, vegetational terraces, and CSEB bricks. Our final embodied carbon stands at just 5.6 kgs of carbon emission per meter square, a clear demonstration of our environmental responsibility.
Moving on. Urban resilience is at the core of our design strategy for Chennai, a city facing acute climate vulnerabilities. Our project focuses on tackling three big challenges: urban flooding, urban heat, and power outages. These affect daily life, causing damages, discomfort, and disruption. So our goal was to design a building that can bounce back quickly, stay functional, and stay safe no matter what. We've incorporated resilience into our design in a very practical way. Is there flooding? We've raised the plinth by 1.2 meters to keep the water out. Too much heat? The parametric facade helps control solar gain and boost natural ventilation. What's more, we've added passive air exchange using segmental arch ceilings, no machine needed. In emergencies, there's a custom fire response system to protect sensitive equipment, and to keep things running during outages, we integrated solar energy generation into the built form. To make the building self-reliant, we focused on three key areas. Our solar slope generates a substantial amount in addition to a diesel generator that covers up to 3.5 office working days. We use rainwater harvesting and store 52,000 liters, which is 67% in water positivity. A terrace garden supports food security with fresh herbs and vegetables, and dry storage helps us stay stocked up. So overall, it's just not about surviving disruptions, it's about getting back up, staying comfortable, functional, and future ready. We've incorporated various strategies to reduce CapEx and OpEx: alternate use of materials, design optimization, recycled furnitures, repurposed assets, and energy efficient building designs, along with design aligning with SGRB and Griha standards, help in reducing our CapEx. Conservation, planned investments, optimized maintenance, resource management all contribute to offsetting running costs and reducing the OpEx over periods of time. Affordability is assessed when a building is used by its owner, not being rented out. We calculate return on investment using avoided rent, operational savings, and productivity gains. For example, our solar slope generates an energy of 43,000 kilowatt hours per year, and our building only uses 34,000 kilowatt hours. That results in approximately 29,000 rupees of profit per year. With that, we have estimated a payback period of just 10 years. Maker House solves key user problems through unique features, meaningful benefits, and performance attributes. This distinguishes it from other alternatives in the market. Innovative design and construction that is easily replicable, renewable energy and efficiency through autonomy, sustainable water management through rainwater collection, eco-friendly construction materials that have a lesser embodied carbon, courtyards that bring in natural light and ventilation, keeping morale high, earthen arches that maintain a low carbon footprint. Terracotta meets 3D printing technology through our very own radiant hex facade, and effective spatial planning that maximizes the floor area.
Thank you for hosting us in this lovely campus. But this isn't Infosys Mysore. We are not here with mega budgets, but with a big ideas for small sites. Maker House is a prototype for MSME offices designed to be eco-sensitive and strive towards energy and water neutrality. It's a practical solution for tier 1, 2, and 3 cities where space is tight, resources are limited, and aspirations remain high. With Maker House, we've shown that attaining net zero is possible even in restricted urban conditions. Through smart design, passive strategies, efficient systems, and reuse of materials, we've minimized energy and water demand. In addition, rainwater harvesting, e-waste management, and a terrace garden, this project proves that sustainability can be practical. We are happy to announce that Maker Horse can be qualified for IGBC Platinum rating with 75 points. This isn't just a concept or a one off experiment, it's a prototype for MSMEs that often get overlooked in a green design conversation. More than just a building, Maker Horse is a call to action. It adapts to varying user needs and can be molded to fit different urban contexts. It gives shape to a hope shared by many small business owners to grow sustainably, responsibly, and independently, like Mr. Natarajan. We are not here with a dream, we are here with a solution. Maker Horse is making itself, and now it's time for you to make it yours. Thank you.
Thank you, Team Mar. That was a very insightful and entertaining presentation. So let's hear from the jury members. Dheeraj, I'll start with you.
Okay, I don't have any questions, honestly. I had just one question in the end. Sorry, I had just one question and that got answered in the end. Thank you to you. I was about to ask that once you have done all these things, are you planning to apply for IGBC certification? And you answered it. That was the question I had in my mind. I mean, amazing work done. One difference which I find, okay, not to take away the credit again from anybody else who has done so much of good work. In your 20 minutes allotted to you, you mentioned about the person who is driving this project multiple times. I think his involvement, his personal involvement in the project makes a lot of difference for the students who are working, getting encouraged not only to work on it, but to excel on it and deliver a feeling which I will probably call as aha feeling kinds, So I wish everybody, every student tomorrow, next year, year after next, always gets one Mr. Natarajan to all of them. Thank you.
Thank you, sir.
Yeah, similar feeling, like, so, the presentation came last, but it was really good. It topped off. I think attention to detail is what I like. A lot of industry collaboration, but the learnings that you got and how you integrated various things that you got from different people into one design, that's what like stood out, right? You went to Auroville, you looked at bunch of things. You went, you looked at arch roofing systems, but also you looked at water treatment systems, but you also looked at something else. I've been through this and I know just wrapping your head about some of these things is difficult, but having taken that, put that into a design concept, and the fact that you didn't think about, and this was the pitch that I really liked, the starting statement saying, how do we make this replicable, right? It should not be a one-off design, right? If you say, this is going to be super difficult, I just do one, your impact levels are curtailed. But you show them that this is a concept that can get replicated. Obviously, site conditions, climatic conditions, a lot of things will influence a project, but showing that there is flexibility, there is a chance to do it was really good. Like I can go on like simple things like just a column design, right? How you stepped it up. You talked about EAF steel, right? Because a lot of people are talking about embodied carbon. I still question some of the numbers and say 96% reduction kaise hoga, but then it's good. At least you've taken that effort to look at the details of certain aspects, right? And dealt with it. I'm really, really happy. I think a lot of effort has gone into this. I know there's a team behind the four of you people, and I really appreciate all of those people too, your faculty or whoever has helped you with all of that. So yeah, and like sir was saying, it's all a learning for us, right? Your learning is my learning. Your learning is everybody's learning. I think, there was something to learn from each one of the teams, And I think when we walk out, if we say this is a learning that we have and not what I learned or what I presented, I think we'll take away a lot of things, right? So I'm pretty sure there were a lot of small things that we saw in each presentation that I would like every one of you to look back and say, this, where can I integrate this? What value is this bringing to the design, and why it is important. Yeah, good presentation.
Thank you so much.
One question I have. The hexagonal thing looks great. Did you think about how visually inside, like what the visual quality of the space is going to be? Because it's going to cast shadows, and I would love it if it's in a space that's fluid, like a common lobby area or something like that, and you see the passing sun, and like every time it like just moves, and it's very dynamic. But in an office space, would you would you like to have like patterns on your table that are dynamic, and that's something that you'll have to see and think about. Nothing to take away from your design, it's really good. I think just that one thing, maybe think about it.
Sir, just to answer that, so we have a double glazed glass unit behind the facade, so that will still diffuse the direct the shadows that come in. So it will not be very sharp, it will be diffuse shadows that come in. And the patterns keep moving through the day, so it wouldn't fall onto the workspace, and the furniture layout is movable. So we've made that also flexible, and the people who work are not like in just one place. So that is also being dynamic, so that would add up to the whole workspace.
Yeah, good. Thanks.
Thank you, sir. Thank you, sir.
So you started your presentation by saying that I'll begin with a story. I personally believe in the power of stories. It is an excellent way to make a presentation because you hold the attention of the audience immediately when you say, I want to tell you a story. So that was an excellent beginning. And the other thing is you had innovations in, all the aspects which, SDI has given you, which was very, very encouraging. When you were presenting, I felt that it's a presentation by professionals, not by students. So, I hats off to you people and to the people behind you. Very well done.
Thank you so much.
Thank you, jury members. Thank you, Team Ma'arth.
Why the name Ma-Earth? Can you explain that? What was your thought behind that?
Ma means mother in a lot of different languages. So bringing it everything together, and our whole building is built for the planet. So that is our basic tagline, and hence Ma. Yes, so that's also aligning with it. Can we get 2 minutes to just explain the model?
Thank you. So, everyone, okay. So that was our last presentation in the office building division. Our esteemed jury panel has shown immense dedication for assessing these entries, and I want to thank them. Thank you for all your thoughtful assessment and comments. And I want to congratulate all of the finalists. As a jury coordinator for this division, I have had the opportunity to see these teams submit their deliverables. They have done some incredible work. Let us not forget that these teams have discovered a way to collaborate and do the integrated design during the last 9 months. I think that itself deserves a round of applause. So now this evening, all the jury members will meet up and decide the winner and runner-up teams. So now who will it be? So while we wait in anticipation, don't forget to head to our YouTube channel
to vote for your favorite movie. So you can vote till 5 p.m. today. We also have an exhibition called the Climate Smart Innovation Exhibition, where you get to see innovative building products from the industry that addresses climate change. The exhibition is now open for you all. In a while, you may also proceed to the multiplex zone, which is just 5 minutes from here. Okay. And the people who all are online, stay tuned to our channel at 6 p.m. Watch the 10 exhibitors pitch their products in a bid to win the Climate Smart Innovation Awards. Until then, have a great evening. Thank you.